is here. Alexandre, who is presenting biomechanics sensor node for virtual reality?
No, it's gonna be Diego Diaz, one of
Diego
the
Diaz.
co-authors. Yeah,
Is here?
it's me. I'm here.
Okay, great. Welcome. Great.
Thank you. Thank
So
you.
you present also the other two papers or only one?
Two papers.
Okay,
Biomechanics
great.
sensor nodes and the next one.
Great, great.
Okay.
So I guess in a couple of minutes we can start.
Okay.
So let me start wishing to everybody happy ICCSA 2020. It's a very special occasion this year because we are connecting from around the world. I want to thank you particularly Damiano Perri for his amazing work organizing the technological part. And I will pass him the word now to introduce BRA workshop. We are co-organizers, and I guess this year was really a very interesting edition of the workshop. Thanks to all attendees, and have a nice day. Please, Damiano.
Hello, everyone. My name is Damiano Perri, and it is with great honor that I welcome you to the 20th edition of the International Conference on Computational Science and its Application. We are about to begin the session, Virtual and Augmented Reality and Application. This year's session will be very rich. We will have 8 papers to show that cover many areas of this topic. We will talk about innovative techniques for improving the teaching of mathematics, geometry, and computer science in schools. Other papers will analyze the best techniques for improving the living condition of people with disabilities. This and many other topics will be addressed this morning. I will then pass the floor to today's first presenter. Okay, please, let's start the presentation.
Damiano, please say the title of the paper.
Yes. The first paper is Wearable Device for Immersive Virtual Reality Control and Application in the Upper Limbs Motor Rehabilitation.
Can I start?
Yes.
Okay.
You have 8
Good morning.
minutes presentation, okay?
Okay, thank you. Good morning. I am Matteo Giglioli, and I will presentation the following paper: Wearable Device for Immersive Virtual Reality Control and Application in Upper Limb Motor Rehabilitation. There are a few points to show why using virtual reality in motor rehabilitation, such as increase patients' motivation, allow the injured limb to control virtual hands in the virtual reality world, help therapists to evaluate the patient's evaluation between sections, and stimulating the patient memories using familiar image in the puzzle. Based on this point, we developed a sensor for the patient arm to control.
Excuse me, can you go to presentation mode, please?
Oh, okay, sorry.
Thank you so much.
Wrong one. 1 second, I forgot where is it. Let's see. No. Okay, thank you. Based on these points, we developed a sensor for the patient's arms to control a virtual hand in the virtual reality environment. The movements of the real arm will be translated in the virtual world. The sensor consists in IMU. There is an initial measurement unit to acquire the motion data, one microprocessor that will calculate the rotation angle of the wrist in relation to the elbows, and a Bluetooth model that will transfer the data to the jigsaw puzzle that is running in a smartphone. The puzzle developed in this project there presents a few options for the therapist to set based on the patient's injuries, such as the hand, left and right, the number of pieces of the puzzle, the sensitivity, that is how the real movement will be translated to the virtual environment. In other words, a small movement in the real of the real arm can become a huge movement in the virtual world. Another option is the image that will be shown in the puzzle, the jigsaw puzzle, and the last one is the hitbox. That is how precise the patients need to be to get the puzzle piece and to put the piece in the right place. This image you can see a little better how the hitbox works. The left hand needs to get inside the green square to get the puzzle piece, and needs to get inside the right green square again and to put the piece in the right place. In this image, you can see how the patient will see the environment without the yellow line, of course, and how the hand can control, the real arm can control the left hand in the puzzle. To evaluate the device in relation to precision, we made it in 3 stages. 1, leave the device still for 3 minutes. The data can be seen in the table 1. Leaving the device for 1 hour, or table 2, and a repetitive test that we made in that can be seen in table 3. In the leaving the device still, the error wasn't higher than 1 degree. And in the precision, in the repetitive task, the highest error was minus 1.2 degrees in pitch angle. In relation to the puzzle, we evaluated the puzzle with 16 healthy volunteers, and the average time to complete the puzzle was evaluated in the minimum and the maximum sensitivity. The volunteers evaluate very well the puzzle. We can see in the table 5 how they answered the questions. And this puzzle will be evaluated in the future works with patients, but because of the pandemics, it cannot be made right now. In conclusion, okay, that wasn't me. In conclusion, a few points that what we made in this project. We developed low-cost equipment to control a virtual jigsaw puzzle. The puzzle can run in smartphone with low specs. The device and the puzzle was tested with healthy volunteers. And as I said, it will be tested in patients in the future. The device precision was very good for this application, and the puzzle was well evaluated by the volunteers. I want to thank the institute that financiated this project, CAPS, CMI, FAPESP, and BRAIN, and feel free to contact me by email or for any reason that you want. Thank you, everyone, for listening. Do you have any questions?
Thank you.
Thank you very much.
I have a question. What is in your opinion, the limitation of your device? It looks very, very, very interesting, and with several very interesting applications. But which is the limitation in your point of view? Which is the critical points? Which are?
One of the biggest problems, limitations, you said, of the device. Actually, there's two big limitations. One of the limitations is not solved yet, but is in process. We are using right now just one device that is in the wrist of the users. Because of this, we can only get the angle between the wrist and the elbow of the user. In the future, we will use 2 or even 3 devices to get all the angles between wrist, elbow, and shoulder, and even shoulder and rest of the body. Because of this, we can track almost every single movement of the patient's arm. Right now, we only are getting this angle between wrist and elbow. The other limitation is that we are using inertial measuring unit, and because of this, error accumulation can occur. Because of this, we need to evaluate this in a real situation to see if this table is really correct. Right now, staying still is really good for application. 1 degree is nothing for this, but in the long run, we need to test with the patients, with real patients, to see if this continues to get this good.
Okay, thank you. I can see any other questions in the chat. So we can start the second presentation. And
Okay. Just 1 second.
Okay, hi everyone. Good morning.
okay,
Can you
the
see my
second
presentation?
teacher.
Can you see
Yes.
my presentation?
Yes, yes, we
Okay,
can see.
okay. Can I start?
Yes, please.
Okay, good morning. My name is Diego Dias. I'm a professor at Federal University of São João del Rei, UFSJ in Brazil, and I'm going to present our paper entitled Biomechanics Sensor Node for Virtual Reality, a wearable device applied to gait recovery for neurofunction rehabilitation. Due to the advent of technology, virtual reality has grown and become increasingly present in our daily lives. Because of that, we are using VR in areas such as education, health therapies, and entertainment. Wearable device and virtual environment allow us to develop solutions for a wide range of healthcare applications. These include the prevention of muscular atrophy, neurological recovery from diseases such as stroke, Parkinson, and Alzheimer. Among the vascular disease, stroke represents the leading cause of long-term disability, and the increasing proportion of survivors from this disease is associated with an increase in patients who persist with neurological deficits. More than half of the survivors from a stroke remain with a severe disability affecting functional independence in their daily life activities. For this reason, rehabilitation programs based on VR have been highlighted as an alternative and complementary therapy for motor recovery. So VR can add the stimulation of a lot of sensor systems of the human body. This way, we can use the VR system as support to other therapeutic interventions to increase the complexity of tasks during the rehabilitation process. These are the gesture recollection family applications, some applications developed by our group. It's a set of immersive and interactive applications aimed at physical motor rehabilitation. The top left application, it's called Gesturing Maps. It's a mixed augmented reality application where the user can navigate the virtual maps of Google Street View using stationary gait movements, so lower limbs track. The top right application is called Gesturing Chair. It's an application designed for wheelchair patients, and it stimulates only the upper limbs with a great range of movement. The concept of dual task is applied here. So we have motor and cognitive stimulation. Many studies report that the use of dual task brings benefits to the motor rehabilitation process. We also have the bottom left application called Gesture Chess, also employs the concepts of dual task. And we have the bottom right gesture puzzle that allows the patient to use their upper limbs to interact and assemble a puzzle. In this application, we use both arms to interact with the environment. Here we have another solution, a tracking solution based on Arduino. We have the A Street, that is a 3D environment that simulates navigation inside the street and reproduce some traffic situations with autonomous cars and walkers. The interaction device present here was constructed using ultrasound sensors and Arduino. This solution was presented at the ICCSA 2018 in Melbourne. I was there, I present this paper. You can see here in the reference. And this kind of device gives us a great freedom of movement when we use the head-mounted display. Using a Kinect, we might have some problems here regard to occlusion, for example, since the user movement might occlude some part of his body. So here we have the proposal of our paper. We have the BSN device that was proposed due to the imprecision and clunkiness of the ultrasound sensors using the Arduino device. In this paper, we present the biomechanics sensor node, the wearable device developed by our group that is composed by gyroscope, accelerometer, gravity, and compass sensor. We also present a unit asset which integrates the BSN data with Unity Engine to make easy the creation of new applications. The development of the asset was carried out, bringing together all the functions implemented in the BSN. So the communication occurs through 4 phases. find device compatible with BLE technology, the BSN identification, the list of found devices and connection requests, send calibration comment to BSN and read the BSN sensor data. We have here define the BSN and connect to a BSN. The first one tracks all devices that support BLE, and the second one makes the connection itself with the armband. Regard to the calibration, after the connection made between the BSN in a smartphone, we need to calibration phase. This phase is used to identify and filter the noise inherent to the sensors. About the data, we can get data as a quaternions and Euler, so we have some functions for it. You can easily use the data already processed by BSN, quaternions or Eulers, or with your header. It's possible to obtain the whole data from a specific sensor, like compass, gravity sensor, gyroscope. You can have battery status, if you want, and step counting processed by the BSN. Here we have an example of stationary gauge tracking translate to the movements of an avatar. In this example, we use it for BSNs, 2 BSNs per leg. So combining their quaternions, it was possible to map the movement of the entire leg. In this example, we are not calculating linear acceleration, so we use 2 devices to perform the movement of each leg. You can see that we have a simple interface to indicate which limb is given device attached to on the upper or lower leg, right and left, for example. We have already achieved some results with the use of VR in rehabilitation for post-stroke patients. In this figure, you can see on the left the oxygenation of the patient's brain at the rest state, the figure A, subfigure A. In the right figure, you can see the same patient right after an intervention using our VR solutions. Here you have a fMRI image. We can see in this figure that the oxygenation of the patient's brain is higher post-intervention. This shows that a large part of the brain is active in the activity supported by VR. We still have to study together with our Brain Institute colleagues and try to realize how this will be translated into rehabilitation gains to the patients and then see if VR really supports the usual therapy protocols. So in this paper, we present the proposal and design of BSN device by the lack of tools that can track the upper and lower limbs. Our solution allows up to 8 devices to be scanned and connected at the same time, enable multiple body parts to be tracked. We also present an asset, which is a set of functionalities for the Unity game engine to facilitate the development of VR applications use our solution. And using both of them, you can connect, calibrate, capture raw data, allow sensor fusion, and motion composition. We have some future prospects. I present to you the gestory family, puzzle, chess, maps. We have the rehab, an application for measure range of motion, often used in the Kinect. And now we have some inertial sensors using for e-house, e-street, and the BSN for VR. Some of our research partnerships, we have some Brazilian university research centers, technology partnerships, IPCD and Embrapa, and the research funding agency. Without them, it would not be possible to develop our solution. Thank you, everyone.
Thank you.
Thank you.
Thank you for the presentation. Any question?
Any question? May I ask you the same question of the previous presenter, which is the critical aspects of your device, in your point of view, sincerely speaking? It was very cool, very, very interesting. But are there critical aspects? Or?
No, I think we don't see any kind of problem in this device now, because it's an improvement of the Arduino-based device. Now I can use 2, 3, 4 or more devices to track all the body. It uses a BLE technology, so we cannot worry about the battery, for example. It's not big, it's really small. You can track in all parts, body parts. So I think you don't have problem with this now. It's a really great device.
Okay, thank you.
Thank you.
Thank you so much.
I think the next presentation is me again.
Exactly, yes.
Let me see. Can I go on?
Yes, please.
Okay, this presentation is about the master thesis of Adegerian Freitas, and I'm one of the co-authors. I'm presenting his paper. It's called Dynamic Adaptive Communication Strategy for Fully Immersive, Interactive, and Collaborative Virtual Reality Application. His advisor was Marcelo de Paiva Guimarães. Fully immersive, interactive, and collaborative virtual reality applications allow users to interact and navigate in synthetic worlds while solving single tasks. When we talk about fully immersive environments, we cannot forget about the graphic cluster that they run the fully immersive environments. It has become the default architecture used to these applications since the beginning of the 90s, when we was presented to us the cave by Carolina Cruzneira. And each cluster may be composed of different types of nodes. The common ones are rendering nodes, file server nodes, input nodes, and master nodes to manage the environment. When we talk about graphic clusters, we have two kinds of architecture: inter-cluster communication. In an inter-cluster communication, we use a local area network to handle data from multiple nodes. And inter-cluster communication, we can achieve that by using a peer-to-peer approach to connect the master and slaves among them. We have some developed challenges that we need to worry about, like the locks, synchronization barriers. We have data lock and frame lock, for example. In this paper, we present a strategy for analyzing the communication between inter-cluster environments, where we can have issues like packet loss, time variation, or jitter, and delay. Our goal here is to identify automatically the connection issues and mitigate them by changing some data networks configuration, like network protocols, topologies, buffering, and data prediction. The developed solution is composed of 5 phases, split in manual and automatic tasks. The first one, the gray one, the process starts by defining the network requirements of the fully immersive, interactive, and collaborative virtual reality applications. We define these requirements using the literature. We have made a systematic review for that. And the second one, the class definition and their features are then defined. The third one, training set. The training set is automatically created by capturing data using a network simulator. It's called NETEN2, Network Simulator. This data set is saved and used for the internal classification of the sample. And finally, the classification. It's ready to be used directly at runtime by the library to adapt the network communication. The graphic library must be tailored to capture packets, trigger the classification, and adapt the communication at runtime. For example, to choose another network protocol, change the network topology, or perform some data prediction. We called our tool to declassifier that automates the training, classification, and visualization of results, and the configuration of the tests is carried out via its interface. We use a supervisor pattern recognition technique based on graph-based to classify the variables. It's called OPF, Optimus Path Forest. The OPF solution is based on the supervised research that uses a complete graph as an adjacent relation. So the OPF aims to assign a correct class label to each new sample, and these compete among themselves to conquer the remaining samples. This process results in optimal path trees. So how the OPF works? In our example, we have 27 classes, and each class represents a partner. Whenever a new sample appears, we can talk about is like a packet in the network. It's going to be a new sample. The classes compete each other to classify this sample. The class that comes closest to the new sample will be the label of it. So here we have we define some linguistic terms, not harmful, and very harmful. And the first table lists the range of values defined for each input variable: packet loss, time variation, and delay. Consider and shows their consequence to the user experience. As I said, these values were based on a systematic review. The attributes shown in the table were based on the minimal expected requirements for a graphic application with a 60 frame per second. The information for each frame is transmitted by message, so we have a message exchange in our graphic cluster that results in 60 messages per second. Each input variable is used to measure a specific problem associated with network communication, and it is related to the network communication diversity. And then in the second table, the classes of adversity, we have a combination of 27 classes used to define the type of dynamic adaptation required from the communication library. We can see in the figures the values obtained for each variable and its classification. We use some different colors to enhance the user's cognition. Green to no problem, yellow for harmful problems, and red for very harmful problems. In the left figure, you have low values for the three variables, so it was classified as no adverse was found. Was transmitted 6 packets, low delay in a low time variation, so everything's okay. In the second one, when we increase the delay in the time variation, the example is classified as a harmful problem. So you can see we have a huge, a medium delay in some time variation. And the third figure, you have, according to the classification, we have a lot of delay and a huge time variation, so it's classified as a very harmful problem. The most influential variable here is time variation. And one of the benefits of using a classification of
Please, Diego, we can't hear you. Diego, please check your microphone.
Okay. Are you hearing me?
Yeah, can. Yes, please.
Okay. Our strategy was based on the use of supervised pattern recognition technique called OPF. We classify these variables into 27 classes of adversities. This makes it necessary to conform to strict timing dependency, meaning that network communication is likely to experience bottlenecks caused by problems such as packet loss, delay, and time variation. To train our classifier, we use data collected by the TANK simulator. And the G-classifier tool automates the training, classification, visualization of results, and the configuration of the tests. The results can be used directly by any library to adapt network communications properly. We can use libglass, for example. That's a solution that we have been using in our graphic cluster, in our mini cave. Thank you. If you have some questions, I will ask you to send emails to Marcelo De Paiva, the advisor of this work. He will be glad to answer you.
Okay, thank you. Okay, we can start the next presentation. And I'm Damiano Perri, and now I present the article An Immersive Open Source Environment Using Godot. The other contributors are Marco Simonetti, Federico Frenguelli, Alessandro De Angelis, and Ilaria Cuccaro. We will now see a brief introduction, then we will describe the system we have created, and finally, we will make the final consideration. We present a simple implementation of a virtual and augmented reality immersive environment based on free and libre open source hardware and software, and the ATC Vive system used to enhance the immersive experience of the user and to track his movements. The sensation of immersion has increased and stimulated using a footplate and a Tibetan bridge connected to the virtual world as augmented reality applications and implemented through an Arduino board, thereby adopting a low-cost open source hardware and software approach. The proposed architecture is relatively affordable from the cost point of view, easy to implement, configure, and adapt to different contexts. It can be of great help for organizing laboratory classes for young students to afford the implementation of virtual worlds and augmented reality applications. The project was designed thinking about of the real available space. For this reason, the experience consists in a circular path. The player will start the game at one edge of the real room. He has to reach a footplate that is placed both in the virtual and in the real world. Get on it and press a button in the virtual world that will activate its movement. In this slide, we can see an image where we can see a player, a real player, the footplate, and the button. When the footplate is activated, in real world, it starts to vibrate, while in virtual world, the player is moved to the upper floor. Upstairs, there is a path where the player can move and walk until it reaches the bridge. The bridge is able to detect the collision with the player, so when he starts to walk over it, some forces are applied to the bridge to simulate the behavior of a suspended bridge in the vacuum. The path to be followed by the player is circular in the real world and developed upwards in the virtual world. This technique is designed to solve room spacing issues and to give the player the feeling of walk a long way. We can see now a full scene in Godot. We can look at the platform at the bottom, the grass and the environment, and the platform at the top. It is fascinating how the virtual reality can influence the player's sensation in the same way of real world. Even if the player knows that all the system is virtual and not real, when he has to jump in a vacuum, he feels scared and does not want to jump. The aim that the whole project would reach is to mislead the player's feeling. For this reason, we made a path developed upwards in which there is a suspended Tibetan bridge, shown in figure. Furthermore, we add a wooden footplate that is present both in virtual and real world, and its position is mapped at the same point. In this way, when the player reaches the footplate in virtual world, he will reach it in real world too. Under the footplate, we added some vibration motors. We can see an example in this picture. The vibration motors is used to mislead the perception of the player. When the player goes on it and press the button in the virtual world, the motors will be activated. In this way, in the real world, the player is affected by some vibrations that give him some feeling of instability, while in the virtual world, he is moved upstairs, ready to start exploring the virtual world. Please remember that the player feels the vibration when he stays on the platform. We tested the environment using these hardware components. We use the ATC Vive as headset. The controllers are represented by the hands of the player. We use 2 base stations and trackers. We tested the platform with an Intel i5 4590 and an AMD FX 8350. As for the GPU, we test the system with an NVIDIA GeForce GTX 970 and an AMD Radeon RX 290. The system is able to work with 4 gigs of RAM. We used an Arduino Uno board and 2-stepped motors. We tested the system with Windows 7 Service Pack 1 and later Godot. We used Godot for the development of the environment. We used Blender for the development of the object, and with Godot we assemble the scene and the scripts, and we used Arduino IDE. The project's purpose is to create an immersive virtual reality experience from the design to the implementation. Through this project, we tested the Godot's efficiency for virtual reality games. We obtained good performances both in physics, simulation, and graphics quality. The current project was presenting only a footplate as an interactive object. Our goal is to add more interactive objects. We could, for example, introduce a fan fixed on the ceiling. The fan will be activated with the vibration motors placed under the wooden footplate to simulate the wind effects. Furthermore, the vibration system can be applied to other static objects. Thank you for your attention.
So we can connect when it is or are there any questions?
Okay, I think that we can start with the next paper presented by Marco Simonetti. The title is Teaching Math with the Help of Virtual Reality.
Yeah. Just a moment, please. We'll prepare all paper.
Damiano, sorry. I guess this is the second. We have a break now.
Marco, please share
Tell me.
your presentation.
Yeah. Okay. Just a second. Can you see it?
Yes, it's okay.
Okay.
Guys.
Okay.
Yeah, sorry, just a moment. I think that
But we are seeing the GT screen. Please share the presentation.
Excuse me. We have a break now.
the presentation of Professor Simonetti is on the second section of the PRA, so we can have a break.
We have a break now. We start at 10.
Okay.
Thank you.
Marco, please turn off the sharing screen.
Yes, okay, I'm doing. I was taken by surprise.
Okay.
Excuse me, I remember you all that we are going live on YouTube. So if you want, you can turn off your cameras. Thank you.
Marco, I guess we can restart the session, the second session of VRA workshop.
Okay.
So it's your turn, please.
Yeah. Okay. Thank you. Can you see my screen?
Yes, perfect.
So I can start. Well, good morning to everyone. And the title of our work is something wrong. Okay. Can you see my screen?
No, you lose the
Sorry.
presentation disappeared.
Yeah. Okay.
Share again the screen.
Yeah.
Okay.
I'm doing.
Thank you, Marco.
Now, is that okay?
Yeah.
Okay.
Yeah, it's better.
Okay, I can start. As I said, the title of our work is Teaching Math with the Help of Virtual Reality. And my name is Marco Simonetti, and I'm at University of Florence in Italy. We have divided this presentation in 3 parts: introduction, description of the system, and conclusions. In this work, we want to introduce a learning system based on virtual reality and augmented reality for studying analytical geometric structures that are part of the curriculum in mathematics and physics starting from senior high school classes. And during our work, we were guided by a specific goal, the possibility of giving a real and visual form to some abstract objects of mathematics in order to improve students' comprehension. At the very beginning, we directed our attention to a limited number of functions which are used in senior high school classes, such as the representation of trajectories in the Cartesian plane and some surfaces in the 3-dimensional space. Among functions we have chosen, we find f of x equal to sine x, where x belongs to a real number set. And we can say this is a well-known function to students because they usually use it to solve analytical and geometric problems. We can say it is also commonly used in physics to model periodic phenomena such as sound and light waves, or even changes in average temperature during several intervals of time. Another function we have chosen is f of z equal to z squared, where z belongs to complex number set. We have mainly focused our attention on its real and imaginary part because they are very important in the study of non-Euclidean geometry and in the theory of general relativity. We studied the real part of z squared, and that is f of x and y equal to x squared minus y squared. And we can say this is a classic example of a saddle surface. That is a smooth surface containing one or more saddle points. Saddle surfaces have negative Gaussian curvature, which distinguish them from convex elliptical surface, which have positive Gaussian curvature. And here we can see the suggestive descriptive power of mathematics, and I guess rather an appetizing use of mathematics as well. The imaginary part of z squared, and that is f of x and y equal to 2xy, and this function is another example of hyperbolic paraboloid surface and its use, or more precisely a rectangular hyperbolic paraboloid. And above, we can see an example of a roof built with this shape. And we can say they are very common in the world. Another function chosen, this function is an example of a bidimensional natural logarithm useful to describe some astrophysical object. Or another function we have chosen, this function is an example of a bidimensional damped sign useful to describe objects, mainly in fluid dynamics, electronics, and telecommunications. Okay, now we can dip into the description of the system. So once we have chosen the functions to be represented, we had to make the choice as well that allowed us to define the environment to be used. So we have split user experience in two different parts. One uses VR, the other uses AR. In both cases, the graphic engine used is the same, Unity 3D. The VR environment is generated and compiled by WebGL technology, and this choice lets the entire application be compatible with all devices, computers or smartphones as well, since the environment is usable through a web browser. Okay, here we can see the image of Unity and WebGL running in a web browser. And the AR environment uses the Vuforia framework. The program created is an APK installable on Android smartphones with 7.0 version, or greater than this, of course, operating system. Vuforia is an SDK that allows you to analyze the video stream recorded in real time by the phone camera using vmarks. Okay, here we can see example of vmark to draw the function natural logarithm of x squared plus y squared. And this is the effect. Once Vuforia is installed on a mobile device, simply activate the app and frame the relative vmark with a webcam to see the desired object appear. On the right, a three-dimensional image generated by Vuforia for the object described by the previous vmark. Okay, now we are at the final part of the presentation. Our approach aims to give wants to give the students a wider set of objects to study and focus on by simply picking out those of greatest interest. Furthermore, we find it interesting to know the degree of absorption and emphatic response of students to the system, sensations, disturbances, emotions. At least feedbacks from students will be evaluated so that we can improve the experience and make the AR and VR environments more interactive and attractive. Thank you for your attention.
Thank you, Marco. Are there any questions?
Okay.
So please, Marco, proceed.
Okay, yes. I'm seeing that if you don't have any question, we can go on with the next presentation.
Okay, it's me, Marcel. Can I share my window?
Marco, please read the title of the paper.
Yes, I read it. paper is a virtual reality simulator to assist in memory management lectures. Luis Freitas, Alex Ansioto, Rita Guimar. Am I right?
Guimarães. Yes.
Okay, you can go ahead. We can see your presentation. Okay, you can start.
Okay.
Thank you.
My name is Marcelo. I am from Federal University of São Paulo, Brazil, and the title of this paper is A Virtual Reality Simulator to Assist in Memory Management Lecture. I am supervisor of this work. The ability to grasp and manipulate abstract ideas is a vital element of computer science. For example, when students are developing an algorithm. We present here an immersive and interactive memory management environment to assist teaching in operating system classes. So we conduct also a case study with 80 students. We hypothesize that memory management concepts can be better assimilated by undergraduate students when the learning process is supported by virtual reality. And so the students also did a test about the functionality and the usability of your simulator. We found some similar simulator in the literature, but none of them offer an immersive and interactive learning environment. So to build our simulator, first of all, we did a survey with 10 teachers, and this survey allowed us to develop the simulator. When the simulator starts, first the students have to choose the technique, management technique to allocate the process. So can choose, for example, the contiguous technique or non-contiguous techniques. So the simulator starts. When the simulator starts, he can create the process, delete process, and can see the data about the process in the process control block. That's a table that has all the information about each process. So the students can also see the elements of the environments, like the processor, hard disk, and so on. So here, the teacher can formulate a hypothesis about an algorithm and ask to the students to run the experiment. Here I have some screenshots of the simulator. So we can see the motherboard here and on the left, and the RAM memory, the process control block on this screenshot. We have here also another screenshot of we can see some box here of the RAM. It means that this area was allocated for a process. And here we have the table, the process control block. We can see details about each process. Here we have one of the students. So we build a research question that is our 3D simulator a more effective approach in teaching memory management than an expositive lecture? So this allows us to build the hypothesis. The new hypothesis is there is no significant difference in efficiency between the two teaching strategies, and the alternative hypothesis is there is a significant difference in efficiency between the two teaching strategies. So this is our experiment setup. First, we ask to the students to answer a profile questionnaire. After that, we divided the 80 students in two groups of 40 students each one randomly. And after that, the first group had an expositive class, and the second group had used the 3D simulator. This phase spent 30 minutes. And then finally, all of them answered 12 questions about memory management. So we have some results here. From the profile, all students had no knowledge of concepts of operating systems. 38% were female. Students were between 16 and 53 years old, but half of them were between 17 and 19 old. Here we have some data about our the grades about the questionnaire. We had 12 questions. So we have the mean here. The mean was 6.8 in the expositive class, and the 3D simulator, the mean was 10.4. We calculate also the p-value, and the p-value allowed us to reject the null hypothesis. So the result seems to indicate that using the 3D simulator to teach memory management is a better approach than expositive class. Was a better approach in this case. So we also did the functionality usability test of our simulator. The second group, that is the group which uses the simulator, they answered this 12 question also. Here we can see some example. We can see the questions. For example, when a process is created, it is possible to visualize its memory allocation. We can see that it get a good approval, but we can note also that we had some things in the simulator that we have to improve. For example, about the discomfort in simulator, we can see that some students were not so totally comfortable. So this test allowed us to realize that we need to improve the simulator also. Conclusion: this research presents an immersive and interactive simulator for memory allocation. The experiment results showed that the group with used the simulator was significantly better than the control group in terms of achievement in memory management learning. And in the future, we plan to improve the simulator, adding new techniques, allocation techniques, and creating better 3D models. That's it. Thank you.
Thank you.
Thank you. Any questions? Is there anyone who wants to ask any questions?
Just to share the impression, it was a very well conducted study, and I guess it's still a proof of the goodness of the immersive approach in teaching, let's say, difficult concept, and the students may take benefit of these techniques. Thank you, Marcelo.
Thank you as well.
Okay. I guess if there aren't any questions, we can go on. What do you think, Osvaldo?
Yes, please.
Yeah, okay. So we can go on with the next presentation. And motivational evaluation of a virtual reality simulator to teach disk scheduling algorithms for solid state drives.
Okay. Well, my name is Marcelo, and this paper is in the same context of the paper before, but now we teach disk scheduling algorithms for solid state drives, SSDs. So computer science major demands innovative training strategies able to adapt to all technological changes that are happening. For example, in recent years, it has become common to adopt SSDs instead of hard disk drives. So in the operating system, have now to teach these disk scheduling algorithms. We create a full immersive interactive simulator. We did a motivational analysis of a virtual reality simulator to teach this subject. We also conducted a case study with 38 students, and we compared a 2D environment running in a desktop versus a 3D environment running in a Google Cardboard. In the simulator, we implemented two algorithms. The first of them was the NUP. This algorithm works according with the FIFO, first in, first out request, IO request. And another algorithm implemented was the PIQ. This algorithm was designed to explore the SSD parallelism. So it is based on the batch concept. So it orders the IO requests without conflicts into the same batch, and the IO requests with conflicts into different batches. Here we have the screenshot. We have two screenshots of our simulator. This on the left, the NUP algorithm running, and the right, the PIQ running. So the student, when students is near from the bench, he can see the details about the SSD. So all the components of SSD. He can see also the one animation of the IO requests, and he can listen some audio explaining about the advantages and the disadvantages of this algorithm, and he can read some tests also, and so he can move from a bench to another bench and learn about all the details about SSD and the algorithms. To analyze the motivational in this simulator, it was based on the ARCS model. The ARCS model have 4 categories that we considered. First of them was attention. It refers to the learner's interest in the activity performed. Another one is relevance. It refers to increasing students' interest by connecting their peer experience to the content provided. And another one is confidence. When the students believe that they can meet the objectives and that the cost is adequate, their motivation increases. And the last one is satisfaction. It refers to how much the students are proud and satisfied with what they have achieved during the learning process. So here we have the questions. Considering the ARCS model, we have 9 questions, and and we have the categories here. Each question was associated with a category, and we also consider in this evaluation the Kirkpatrick model to use the category learning. So we have 3 specific questions for the learning also. This is our experiment setup. First we divided the 38 students in 2 groups, randomly, the free time. And after that, we divided we had the 2 groups. The first group used the simulator in the desktop, and the second group used the simulator in a Google Cardboard. They used it during 10 minutes. After that, all of them answered the questionnaire. Here we have the results. The mean of the desktop approach was 3.6, and the immersive approach was 3.8. The grades was, we adopted the Likert scale to have these grades here. The immersive approach received the best grades in 7 questions, while desktop was better in 5 questions. So we analyze considering which category here. If you think about attention and confidence, they got best grade in the immersive approach, and satisfaction and relevance in the desktop solution, and the learning was similar in this case. This paper aimed to investigate the motivation aspect comparing the same simulator running two versions in 2D and 3D for teaching disk scheduling algorithms for SSDs. So we evaluate the results indicate a motivational increase in the 3D environment in some aspects. It also shows that further investigation is necessary. It was also noticed that the 3D version kept the students focused on her class. During the tests, the Google Cardboard solution showed higher levels of participation. In future, we plan to improve the simulator, adding new algorithms, and we have also to improve the environment, the 3D models. That's it. Thank you.
Thank you, Marcel.
Thank you, Marcel. Well, any questions? No? Okay. I guess we can anticipate the next presentation if you are ready. And the next presentation is new package in Maxima. Emmanuel Sobrino, are you ready?
Yes. I'm ready.
So I give you the word.
It's okay.
Okay.
See presentation?
Yes, but you have to reshape the presentation because it's too. No. Oh, okay.
Yes, okay?
Yeah. Much better.
Okay. Good morning. My name is Emmanuel Enrique Sobrino Merino. I belong to the investigation group and geometric and symbolic calculation in which camp of representation of the UCP, Universidad Nacional de Piura, in Peru, together with my college, the Dr. Ricardo Vélez Moro León, and the Magister Robert Ipanakechero, and the Magister Jose Mechato Durez. Next, I present of the result of the research work entitled New Packet in Maxima to Guri axonomet project from R4 to R3 and visualize objects immersed in R4. The Pocket theorem and programmation is based on the theorem Pocket, which affirms that every 3 dimensions can represent the projection in splice you can see in the figure. Axonometric projection from R3 to R2. There are infinity ways the projection of from RC to R2. The most using is descriptive geometry, diametric, trimetric, isometric. Apply Pocket theorems and apply the Pocket theorems. 3 vectors are staged R2 to get matrix of immersion from R3 to R2. See the matrix. Using in anal ID, are projection from R4 to R3. Yes, the plotting in the more the curve would have type foreign in the code. The disposition of vectors shown in the figure can you see the four vectors as linear combination from our three basis vector E1, E2, E3, and the four ties is RAL1. Four vectors I take are in R3 to get the matrix of immersion from R4 to R3. The packet R4 projections are example. After loading the packet in the Maxima software, which shows some commands that allow the projection of the curves and the four dimensions draw 4D. Draw 4D. The same therefore commands vector is surfaces concepts that we sound now put variation of the parameters, for example, u minus 1, 1, and the v minus 1, 1. Then the isomorphism that exists between C and R2, well, between C2 and R4, is possible to obtain the graphics complex functions, such as if on C the sine C4, C2, and the FC, the gamma. Hypersurface in R4. We present two hypersurfaces, in the same hyperparabolic and the other hyperbolic, where the three parameters involved in the main. In conclusion, maxima packages in the scripts are Earth projection that the park incorporates the plotting, the points, lines, vectors, curves, surfaces, complex surfaces, and solid immersed in R4. Several instructive examples and the two see the good performance in the part are all the given. Thank you very much.
Thank you. Thank you. Any questions? No? Okay. So I guess we can say that the session is ended. And see you on the next session on 11 a.m. Italian time, of course. Okay? Bye to everyone.
Bye-bye.
Everyone, bye-bye.
I want to thank all the authors, all presenters. Thank you so much. We know
Thank you.
how hard is presenting this paper at this time from Brazil. So thanks a lot. Thanks a lot.
Thanks a lot.
Bye-bye.
Thank you.
Bye.
Bye-bye.
Thank you so much.
Bye.
Bye bye. Thank you so much.
Не, Наташ, никто ничего не говорит пока.
Я могу что-нибудь сказать.
Нет, я вас слышу. А вы меня слышите?
Да, мы тебя
Да,
слышим,
слышим.
Отлично.
но
Замечательно.
не видим.
Ну, я знаю, да, камеру я выключила пока.
Слушайте, можно я сейчас быстренько запущу Тихомиру, по крайней мере, чтобы посмотреть, вы слышите, что она говорит? Или
Давайте.
просто пару слайдов.
Пока ничего не слышу.
Так я еще не запустила.
А.
И экран не расшарила. Сейчас слышите?
Нет?
Нет? Так, понятно, я не расшарила. Сейчас я это сделаю. Я, конечно, сделала замечательно. Так, вот, все. Так. Ага. Экран видите? Нет?
Нет?
Не видно? Не слышно?
Нет?
Экран виден, а звук скорее нет, чем да. Попробуйте делать
так?
погромче.
А так?
Что-то есть, но чуть, ну очень тихо, надо громче.
А так?
Еле-еле.
А?
Ну, слышно, что звук, голос идет, но не слышно, что говорят.
В
Понятно.
общем, не работает.
Мгм.
Good morning.
Но если у вас есть второй компьютер, вы можете запустить параллельно на нем звук и подсоединить его к микрофону.
Excuse me, can you hear me?
Yes, we can hear you.
Good morning. I'm Rafael.
morning.
I need your support for this room. So if you have any technical question, you can ask me. Okay.
Okay,
Just
thank you.
let you remind that we are going live on YouTube.
Yes.
For everything, I'm here to help you. Thank you.
Thank you.
Я не поняла, вот что вы сказали? К чему можно подключить?
Ну, запустить воспроизведение на другом устройстве и к микрофону как-то его.
Ну, я микрофон вот приблизила к динамику этого устройства. Вот.
Нужно другое устройство. Он глушит, видимо, то, что он сам воспроизводит, чтобы не было помех.
Понятно. Ну хорошо, давайте сейчас попробую, конечно. Если у нас есть еще время какое-то, вы меня прервите.
Ну, у нас еще минуты 4, да. Ой, не, больше, у меня часы спешат. Ой, у нас еще много времени.
Бармасов. Бармасов. Ладно, получит он у меня. А так?
Не расшарена сама презентация.
Все поняла. Сейчас расшарю. Так как она может быть расшарена?
Она параллельно надо запустить, ну, и там, и там. Тогда...
на двух. А звук-то слышно?
Нет.
Ну, немного слышно, но так же примерно, как и до этого.
А так?
Лучше.
А так?
Ну, более-менее так. А зачем они роботом озвучили?
Ой.
Так не пойдет.
Ну, потому что это самое. Потому что.
Не-не.
Все,
Вы бы
я
сразу сказали, что там робот.
Ну, не знаю, зачитать, что ли, в конце тоже будет плохо. Может, вообще сказать, что она заболела, она вышла на борьбу с ковидом неожиданно. Ее призвали.
Ну, можно зачитать, я думаю, если у вас текст есть написанный, это будет не хуже, чем вот эта запись.
Но все, что вы обсуждаете, еще идет в YouTube и записывается. Как бы тоже имейте это в виду.
Главное вовремя сказать. Спасибо.
Ну, он сказал же, Рафаэль, до этого.
Да, я слышала.
Ну, не думаю, что много русскоязычных. Я скажу пару слов в начале, буквально на минуту. Как бы всех поприветствую, если нет возражений.
Я думаю, что да, стоит это так и сделать.
Угу. Если только мы втроем не будем. на конференции.
Не, ну как минимум докладчики еще будут.
И я еще есть, так что уже
Ура!
больше.
Да, доброе утро.
Доброе утро.
Ну, Александр Владимирович, вы-то с самого утра. Я вас видел там и на секции у Асфальда.
Да, но я хотел это самое посмотреть, эту виртуальную реальность, но там неинтересно. А потом у нас пропал интернет. Я сейчас на даче
Вы
нахожусь.
на даче, да, мы видим, у вас прекрасная обстановка. Красивые картинки,
Да.
горы.
Но пропал интернет. Потом интернет. А потом я хотел Дегтяреву звонить, но пропала еще и телефонная связь. Потом телефонная связь восстановилась, а сейчас восстановился интернет. В общем, все нормально.
Хорошо.
Значит, а кстати, вот, Володя, я спросил Борисыча, а как здесь это показывать презентацию? Я что-то кнопку не могу никакую найти.
Там кнопка снизу, слева, если вы с компьютера именно работаете.
Не, я с планшета работаю.
Планшет не знаю, но вот у меня, когда я шевелю мышкой, появляется кнопка.
Ну ладно, тогда
снизу слева.
я сегодня все равно отсюда уеду, тут ураган предсказывают со сломанными деревьями. Я уеду в город, а завтра я тогда буду с компьютера.
Так а вы до скольки сегодня досидите на наших секциях?
Я поеду где-нибудь часа в 2-3, потому что здесь пик вот этой непогоды где-то 5-6 часов, поэтому мне надо уехать до этого в город.
Кто-то к нам присоединился, но только анонимно.
Здравствуйте, это
Здравствуйте.
Алексей Белошапко.
Алексей, а вы себя запишите в settings, вот тут вот. Справа в нижнем углу, там такие точечки, вот там профайл, пишите себя, чтобы не быть анонимным.
Settings.
У нас 3 анонимных уже участника, я вижу. О, Ваня.
А меня тоже не видно.
Вас
видно, только вы аноним, фэллоу джитсу.
не видно, да.
Сейчас я попробую найти. Так, отправить приглашение, поднять руку. А у меня что-то общий план останется. А у меня нету.
В настройках?
Там, где поднять руку, там рядом должно быть и расшарить экран, вроде так.
Ну вот More Options здесь такие. Это включить-выключить камеру, общий план, остановить трансляцию, добавить конференцию, включить-выключить показ субтитров. Но это может быть от того, что я на планшете.
Excuse me, you are ready to start if you want.
Thank you, but we don't have the first presenter. Where is Degtyarev? I wonder.
Okay, we can wait a few minutes.
I may start with some preliminary words. So, dear colleagues, we are very happy to greet you at our workshop, Scientific Computing Infrastructure. This is already the 6th event in the frame of the ICCSA, or as we used to call it, ICCSA, the International Conference of Computational Science and its Applications. We started with this workshop in the fall 2015 year in Canada month and successfully continued our work at the subsequent 4 conferences in Beijing, Dresden, Melbourne, and St. Petersburg. So everybody are welcome, and we are waiting for the first presenter, Professor Alexander Degtyarev. Maybe I have to call him. go. So our first, do you hear me?
I think it's not Alexander, I am trying to show the picture with the first presenter.
Слышно меня?
Yes.
So I have called him. He told that he doesn't hear. Maybe we start with the second. Vanya, are you here?
Yes, I'm here.
Can you start?
Maybe
Of
let's
course.
wait a couple of minutes.
I think Degtyaryov is here.
Okay.
Okay. Ой. So Vanya, please start. We have changed the first and the second presentation. So our first presentation will be virtual testbed simulation of airflow around ship hull and its effect on ship motions. Presenter Ivan Gankevich, Associate Professor of the Department of Computer Modeling and Multiprocessing System of the Faculty of Applied Mathematics and Control Processes of St. Petersburg State University. Please, Vanya.
Hello. Do you see the presentation?
Yes.
Okay, let's start. My name is Ivan, and my talk is about ship motion simulator that we developed at our department, which is called Virtual Testbed. The first talk had to be about Virtual Testbed, and since we moved it, I will talk about how it is made, from which algorithms and from which mathematical models. My first talk is about airflow solver that we use to efficiently simulate airflow around ship hull. Many ship motion simulators model airflow in order to measure the effect of the wind on ship roll angle and how the stability of the ship changes due to the wind. Since the effect of the wind is much smaller than the effect from ocean waves, many ship motion simulators neglect it and do not bother modeling it. So we want in our simulator to model it without using numerical schemes in order to be able to perform a real-time visualization and to take airflow into account to see the effect of the wind on the ship velocity and roll angle. Our approach starts in a classic setting. We have a system of equation of continuity that describes the conservation of mass, equation of motion that describes the motion of the fluid, and the boundary condition on the ship hull body, which you can see right here. So that cancels velocity on the boundary of the ship. So far, this setting is classical, and everyone starts with these equations. What is different in our approach is the use of the law of reflection to compute the direction of air flow near the boundary and exactly on the boundary. The law of reflection comes from the optical science, and informally you can state it as the equality of the angle of incidence to the angle of the reflection. This law is usually used for light rays, but here we use it for air particles. This approach is unusual, but in the literature we have found that some researchers used this law for ocean waves, which is the subject of my next talk, and so we decided to try it for the air also. The velocity of the reflected air particle is written like this. It has this formula, which is derived from basic geometric principles. And the solution to the system equations from the previous slide is written as the sum of incident particle velocity and reflected particle velocity. And as you can see here, the coefficient C is exactly unity in this case. So on the boundary, the velocity of air particle is exactly the sum of the incident particle velocity and reflected particle velocity. And near the boundary, this solution is more complicated. The main idea is that near the boundary, we have to take into account all the panels of the ship at every point of the boundary and compute weighted average of all these contributions. And the weight here is the quadratic distance to the point from the boundary. The full derivation we have in the paper, and here is just final formulas. So we verified our solution. We compared our solution to the known solution for potential flow around the cylinder. You can find this solution in many sources, and in comparison form, it is written like this. And if we here substitute the coordinates with the radius of the cylinder, we get this this formula on the right. And if we perform the same substitutions, if you apply the formula for the normal and the formula for the velocity for our solution, we get exactly the same formula on the right. So these two solutions on the boundary of the cylinder are mathematically equivalent. So we just found another form of the solution to this equation. And the advantage of our form is that it is easy to generalize for bodies with different complex geometry. And here you can see the pictures of our solution and the known solution. Like they show pretty much the same field. They show the same field on the boundary, obviously, and they show similar fields near the boundary. Its maximal difference is 11%. So after this initial success, we applied the formula to compute the effect of the airflow on the ship roll angle and ship linear velocity. And here we failed to do so exactly with this formula because in our experiments we directed our wind into the starboard of the ship, into the right side of the ship, and then since the ship is symmetric, the pressure on the right side is exactly the same as the pressure on the left side, and our formula doesn't take this into account. So we introduced the coefficient that can decrease and increase pressure on either side, and that way we obtain this result. So you can see that here with wind velocity, the pressure with increase in wind velocity, the roll angle and the velocity of the ship increases exponentially. So, however, in order to bend our ship on the 1 degree angle, we have to summon the hurricane. So it's a very rare occasion on the Earth.
Vanya, you have only 1 minute.
Okay, thank you. It's the last slide. In order to revive hope in our project, we decided to measure performance of the benchmarks. Analytic solvers never fail to produce big speedups in our project. So we had 3 ships of different sizes. We had 3 machines, laptop, desktop, and server, and we had 2 technologies: OpenMP for CPU and OpenCL for GPU. And as you can see here, GPU outperform CPU by an order of magnitude. So at least we can code efficient solvers. So the conclusions: we have found the solution for airflow near the boundary. This solution is mathematically equivalent to the potential flow around cylinder, but we can use it we can apply it to body of any complex geometry. Our solvers have high computational performance, and this solution, unfortunately, cannot be applied to compute the effect on ship motions because ships are symmetric, and we have to take into account something like circular motion or turbulence in order to solve this problem. Thank you for attention. I'm happy to ask you questions.
Questions, please.
Ivan, maybe it's a silly question, but from all I know about two-dimensional hydrodynamics, you have a theorem of uniqueness of the solution. That's why if you find some solution, it would be the same as any other solution that is already known. What was the reason to provide a new form of this solution?
The reason was to find the form of the solution that can be generalized to any to the ship hull of any form that has any geometric form, yeah, that's it. That's it. We need only a solution on the boundary. We don't need the solution near the boundary because we have only one ship in the simulation, and we don't need to know.
Okay, thank you.
Thank you. We are out of the schedule, so I suggest to stop with questions and to start with the first presentation of Professor Degtyaryov. Professor Degtyaryov, professor of St. Petersburg State University of the same department. So the name of his presentation, Virtual Testbed, Concept and Applications. Please, Professor, go ahead.
Thank you. Thank you very much. Are you hear me?
Yes.
Okay. Please. Thank you very much for presentation of my report. Sorry for some technical problems at the beginning. So I will start, and this report is summarization of our ideas and results in the field of the virtual testbed organization. There are points on which I'll focus during my presentation. And what is the main idea of virtual testbed organization? This is an attempt to completely replace the real object and the environment in which it is located with its virtual counterpart. Even 20 to 30 years ago, this approach looked like fantasy and utopia. However, fundamental changes in the quality of and power of computer as well as the global information space have made this approach a reality. The ability to solve complex problems in a increasingly complete and close to nature conditions formulation has led to the fact that the mathematical models have reached such a high degree of adequacy that they can often be used as a suitable for physical as a substitute for a physical experiment if the physics of investigated phenomenon is fully understood. When implementing this approach, we can talk about the advantages of the virtual testbed compared to a full-scale and even more model experiment. Structurally, the virtual testbed consists of 4 blocks indicated at the slide. The main block is the block of models. The study of complex technical object requires the use of many models that describe various phenomena. All models must be interconnected and function in real time. So the testbed is a complex of multi-level applications which requires a distributed computing environment. Here, example of a virtual testbed for marine is shown on the slide. Here you see interaction of technical objects and real sea conditions and control operations in uncertain environment. In order to ensure the most accurate reproduction of the dynamics of the marine environment for such virtual testbed, it is possible to use method of direct simulation. We have proposed, for example, a method similar to finite volume method. Its distinguished features is the division of each step in 3 stages. I mean the step in time. First stage in the when kinematic parameters are calculated for the centers of large fluid particles. For these purposes, the current source data at fixed nodes of Aileron coordinates are used. Second stage, dynamics and or Lagrangian, when Lagrangian or large deformable fluid particles are involved in the free motion. They redistribute the internal properties of the original Euler sails to adjacent space. And the last stage, when laws of conservation of mass or and energy are consistent. This is achieved by deformation of shifted fluid particles. The next step is reinterpolation of characteristics of current in initial nodes of the fixed Euler computational mesh. Here you see some description of the first stage. And here you see the description of the second stage. The limit of time does not allow me to describe this procedure in details. The main advantages of the proposed method is combination in combination with the tensor descriptions of the problem are in obtaining a well parallelized algorithm. Another approach based on the direct simulation of wave surface and hydrodynamic pressure in any points under the surface takes possibility to simulate marine object behavior in real time. Before me and after me, you will see the presentation of several reports that reveal the details of these approaches. And here you see the implementation of this concept in some time before this our reports. And consideration of information technology and data blocks in structure of virtual testbed points on the following aspects. Really, in such content of virtual testbed, we can accumulate all data and use it in the future for different purposes. For example, drawings of technical object created during design process are used in the future to implement the simulators. Training results of operators, navigators, pilots, etc. In simulator are used for modification of the object. The data obtained as a result of different simulation are used to form a knowledge base of onboard intelligence system, etc. So we can consider this situation as a problem of big data. But as we presented earlier in many reports, big data has different nature. In accordance with CEP theorem, we divided it in six different types. In this classification, our system belongs to the type characterized not so much by volume as by heterogeneity and complex hierarchy. Here we are dealing with both data processing and complex computations. In the first case, we should consider the data as a whole. In the second case, data are exchanged between different branches. As a result of the analysis of existing solutions, the following functional models were identified that are
Only 1 minute. Sorry.
Yes, thank you. And that are the most necessary and need to be developed in the universal solution. And finally, the last detail in the concept of virtual test bed. This is a toolkit that allows you to organize the necessary computing environment. From the foregoing, it follows that it cannot be non-distributed. Secondly, solving complex modeling problems is most efficiently possible only on SMP systems. And combining these two conflicting requirements finds the dialectical implementation in the concept of the virtual personal supercomputer developed by our team over the past 10 years. In main idea is to virtualize all components of the computing systems. As a result, we get a very powerful SMP system designed to solve a specific problem. And here you see different developed applications of our virtual test bed concept. And here and at the final, I'll put attention on the following 4 key points of my report. Thank you very much for your attention.
Thank you. Please, questions. Professor, I would like to ask you, your test bed is only for some training, or it can be installed on ship or some vehicle? For decision support.
Yes, it may be used for design of such special systems and for training knowledge base and for general modeling and testing of different specific software.
Thank you. So, any other questions? So we have to go ahead. And now, again, the presentation prepared by Ivan Gankevich and his co-authors, the name Virtual Test Bed, Simulation of Ocean Wave Reflection from the Ship Hull. Please.
Thank you. This presentation is about how to use the law of reflection to simulate the reflection of ocean waves from the moving ship hull boundary. The initial goal of this work was to replace the empirical methods which are currently used in all ship simulators to compute ship resistance to flow. But in the course of our work, we have found that this task is too difficult to solve in the course of one work. So we resorted to simulation of the diffraction, and the resistance to flow is just too difficult to solve it right now. So what we want from the diffraction and radiation, we want to reduce the effect of the reduce the impact of the ocean waves on the ship hull in order to not use damping artificial damping coefficients to make this simulation realistic. Unfortunately, it is not easy to do, so we just simulate diffraction with hope that further research will reveal how to do this properly. So again, we want high performance solver, we want no empirical methods, we want to be accurate in our calculations. The law of reflection, I will not repeat the law of reflection again, because it is the same here. The diffraction of ocean waves is the change of their direction due to obstacles. You can see here in the picture here's the obstacle in the form of the island, and here's the waves, and we have three regions. In the first region, the waves slow down, approaching the obstacle. In the second region, waves bend over the obstacle, and the direction become tangent to the waterline of the obstacle. And in the third region, two wave groups approaching from different sides of the obstacle meet each other and interfere. So our formula simulates only first and the second region, and the third region is simulated exactly the same way as the first one. But the waves are not slow down, but they speed up. So it's the limitation of our approach. The law of reflection for waves is written like this. Here we take the wave direction. It's the vector of wave numbers, third component of which is 0. And we compute the reflected direction the same way as we did for airflow. And we here use this pseudo vector. It's a vector that contains decay coefficient, and we use it just to shorten our mathematical notation. So our approach to solve this problem is to introduce two velocity potentials. The first potential is written for incident wave, and the second potential is written for reflected wave. And if we sum this potential, we get this diffraction picture. Our governing system of equations is pretty much the same as with airflow. We have the equation of motion for the fluid. We have equation of continuity for the fluid, and we have the same boundary condition. The difference is that we have this equation of the plane, which corresponds to one ship hull panel. So this solution is written only for one ship hull panel, not for the whole ship. And if we solve this this problem, we get the following coefficients. So we can see that it's quite simple. And if we want to generalize this solution to the whole geometry, we have to introduce a smoothing kernel. This is the same. This smoothing kernel is used to compute weighted sum of the potentials from each panel. So we sum contribution from each ship hull panel, and we again use quadratic decay. So the potential decays quadratically with the distance. We have the following results. Here in the picture, you can see the ship hull from the top view, and the waves approaching from the backside of the hull. You can see clearly the first region where the wave slows down. You can see the second region. It's where the wave direction changes and become tangent to the ship hull. It is difficult to see here because the hull is too narrow, and if you take the cylinder, for example, you will see this change of the direction. You can see that there is no third region where the waves interfere with each other because our formula can't handle that. And I have the other picture without the ship hull. It's the same view, but without the ship hull. And you can see that the amplitude slightly increases near the ship hull. So it's the effect of the diffraction on the ship hull. Finally, we again wrote two different implementations of this solver. We had 3 ships of different sizes. We had 3 computers with different performance characteristics. And this time we decided to use local memory for to optimize GPU kernels. And this approach proved to be very useful.
Vanya, 1 minute left.
Okay, thank you. This approach proved to be useful. We got like 3 orders of magnitude speed up in in the case of this desktop, which has very powerful video card. So our solver is efficient. So to summarize, initial goal was to replace the empirical methods used to calculate ship resistance. We made the first step towards this approach. We simulated diffraction near the ship hull. Diffraction alone cannot be used to compute ship resistance to flow because its effect is very small on the ship. Its effect is bigger on the islands, but it's not very big on the ship. Our solver has high computational performance because it uses analytic formula and certain optimizations for local memory. And our future work is to incorporate wave radiation from the ship hull and possibly viscous flows near the ship hull to compute ship resistance to flow. Thank you for attention.
Thank you. Please, questions? Oh, I think, if you don't mind, instead of questions, I would like to say happy birthday to Ivan. We wish you.
Oh, thank you.
All the best, all of you, and we appreciate your sacrifice to participate in our workshop instead of celebrating your birthday. So if you have any questions, we can discuss it after the last report, after the last presentation in this section. We will have some extra minutes. So I decide to move to the next presentation. The presenter is Nikita Strublovtsev, a modified algorithm of plotting a wave motion. Nikita is a postgraduate student of the St. Petersburg State University, postgraduate student of Professor Bogdanov.
Hello, can you hear me?
Yes. Yes.
Excellent, one second.
ICCSA on, io adesso faccio così.
Let me try and figure out how to properly share the screen. Nope, that's not the one.
Very good.
Sorry, one second. Let me just move it over there, I guess. Can you see it?
No, only the Russian text.
That's not what I wanted. One second. Okay.
Okay.
That should be working well. Is it visible?
Yes, but
sorry, one
press
second.
Presentation,
Yes,
slideshow.
yes. So I'm trying to check it and see if it's working.
F5. Nikita, F5.
Some reason it doesn't.
Well, if F5 doesn't work, go to slideshow and there press start from the slide. Yeah.
This.
Excuse me, if you have a problem to share in a full screen, try to make the full screen first and then start to sharing.
Oh yeah, sorry, I realized it wants to share another screen for some reason, so apologies for that. Let's see. Nope, that's not the one. Trial and error.
Okay.
Still not the correct one. For some reason, it just refuses to share the proper.
Okay, Nikita, start, please.
Yeah,
oh,
yeah,
wonderful, wonderful.
Finally. So yeah, thank you for your attention. My name is Nikita Strublovtsev. I will be presenting the paper, A Modified Algorithm of Porting a Wave Motion. Extreme waves, or as they are sometimes called, killer waves or rolled waves, are basically long waves of 20 to 30 meters in height, which suddenly arise from the ocean, which with otherwise very little disturbance. They present a very significant threat to ships, even the bigger ones, because of their sudden nature and the tremendous impact force they can impart on the ship. Their study is usually carried out using numerical simulation, which in turn involves a lot of matrix operations. These operations are generally not desired to be to run on conventional CPUs because they're not that efficient there. So there is a interest in porting those algorithms to alternative compute devices. Specifically, in this particular case, we decided to port the algorithm to a GPU-based system. Let's briefly take a look at the underlying equations that govern this whole model. The essential one is integer differential Kadomtsov-Petriashvili I equation, which is presented on screen. Yeah, I will not go into very many details, but that is basically what is used throughout the model. The important thing is that the equation is basically transformed, and then the linearized implicit finite difference scheme is used to numerically simulate this whole thing. Boundary conditions are set so that the values at the edges of the simulated model are set to 0 and smooth over, well, as smooth as possible. Since the model is basically encapsulated, we need to generate a wave somehow. For this purpose, we use the one second. For this purpose, we use basically a wave generator, which is a rotation ellipsoid with parameters presented on the slide. Here's how the visualization of the model looks like. As you can see, it has a generator in the center where the wave is being produced, and then the impacts is moved to the edges. Now let's talk about how we ported the algorithm. Essentially, algorithm boils down to several steps, or like an integration of a differential equation. First, we need to calculate two derivatives, which is a simple step. Then we need to take two integrals. One is using Euler method, another is using what is called in English literature a diagonal matrix algorithm, and then repeat over basically each time iteration. Second. So yeah, let's talk about some, I guess, specifics. Essentially, we have a situation where a matrix is operated upon by several functions. Since the matrices are like matrix representing the model is very large. I mean, we can scale it, but any model of interest is usually represented by a significant matrix. It unfortunately has to be placed into global memory of the device, which is very slow. This already presents a significant opportunity for optimization if we can cut down on the number of reads and writes to global memory. Furthermore, since we have to store a lot of intermediate results between steps, we essentially have to create not one, I mean, we have to store not one, but 7 different
Nikita, 1
matches.
minute left,
Yeah,
please.
sorry. Yeah. And thankfully, we can reuse one of the matrices, basically cutting down the number of overall matrices to 6. So what about those steps? Thankfully, in early method, calculations of the functions themselves is independent, so they can easily parallelized. But the since it involves an accumulation process, the accumulation itself has to be done sequentially. So the process is not entirely parallelized, but most of the intensive operations can be safely parallelized. During the second step, we have to do 2 runs. One is a forward run and one is a backward run. In both of them, each row element is dependent on 2 previous iterations, which we have to store. And for this particular purpose, we use local memory because it is extremely fast. Thankfully, each row is independent of each other, so it is theoretically possible to completely parallelize them over different devices if need be, although we've not done that in this particular case. During the forward run, we also need to create and store intermediate results, for which we use a specific intermediate matrix, which we store in its entirety in global memory. A result of that is used in the backwards run. Thankfully, we don't need to store or output intermediate results during that step. We only care about the end result of this operation.
Nikita, go to conclusions, please.
Yes, that's exactly my point. So here are some timings. Although comparing CPU and GPU directly is not fair, you can see that we are able to achieve significant speedups from basic porting to the optimized porting. It is worth of noting that trying to do asynchronous execution did not really give much of a performance boost. So in the end, even a simple porting of the algorithms managed to achieve about 20 times the speed up, despite technically significantly lower GPU speed, and utilizing additional optimization as the one I talked before, we managed to achieve a final speed up of more than 90 times. Yeah, thank you. Any questions?
Yes, please, questions. Nikita, and can you tell what are the reasons of such waves, such awful waves? Are your investigation clarify this question or not?
Well, unfortunately, I myself am not entirely familiar with the physics side of this problem. I'm mostly focused on the programming side. So as far as I understand, the exact reason for generation of those waves is not entirely understood.
Okay, thank you. So we have some extra minutes.
I have a small question, if possible. So, Nikita, you didn't have enough time to talk about this, but I will ask you the question. So can you say a bit more about the performance of the solution and what hardware you used? And those different configurations of GPU, maybe you can also clarify them a little bit more.
Yeah, so the original algorithm was basically a Fortran implementation, which ran on CPU. As you can see, it is significantly slower than the GPU ones. Then we basically had an iterative process of porting and optimizing all the steps and trying to figure out how to maximize the parallelization of the algorithm. Even the basic GPU implementation, where we just managed to parallelize inter-row dependencies, managed to cut down the time very significantly. And once we managed to parallelize an in row, basically, once we got down to cell level parallelization, we achieved the biggest speed up ever. We also experimented with asynchronous calls because at least the initial assumption was that by overlapping different types of operations, for example, reading and calculation, we can achieve additional speed up. Unfortunately, it doesn't seem to be the case, and the best approach was to bundle the reading and writing operations together because of the architecture of the memory access of the GPUs. Essentially, it is significantly more effective to access memory in big chunks than to try to write and read values one at a time.
And what was the hardware again? What was the CPU model and what was
the hardware was just normal for this particular set of parameters. It was just like consumer grade. I think the processor was Ryzen. 1 second, let me find it. AMD FX. No, it's a GPU. GPU is FX 8550. And processor is AMD R9 380. The difference in clock time is quite significant. For example, GPU is about 4 times has 4 times slower clock speed, but the parallelization potential, as you can see, creates very interesting results. I think the full specs are presented in the paper.
Thank you.
Any other questions? So I think we have maybe 5 minutes for discussions. If anybody have questions concerning the previous presentations, please. Any conclusions? If no, then we have, I think, 15 minutes break, and after that, I pass my duties to the next chair, Vladimir Korhov. Thank you, everybody, for your cooperation.
Thank you.
Thank you.
Thank
you.
Okay, let's start getting ready. I would propose the first speaker, Oleg Yakushkin, to try to share his screen and to say something so we can check if it works properly. And we don't lose time.
Yes, hello. I'm
Yes, we
here.
can hear
I'm
you.
glad to meet you all today. And now I'll try to share my screen with all of you. So give me a moment. Okay, this and share. So it's going to start sharing right now. Do you see it?
Yes, we can see it. But
Great.
it's in the album. Do you think you can rotate it and make it
Rotate it.
landscape?
I can start the preview like this.
No, we can only see the half of the screen.
Oh, all right. Let's try it one more time. Bam. Bam. And I want to share the entire screen. This one. All right. Is it better now?
Not really. We can see two screens of you. Okay, now it's good. Now it's good.
Now it's good.
So.
Okay, so let's wait for another minute.
Yeah, all right.
Then we'll start.
Spoilers. Sorry.
All right, so welcome to the second part of the Scientific Computing Infrastructure Workshop. And we welcome our first speaker, Oleg Yakushkin from St. Petersburg State University with his talk on service-oriented PetriNet model. The floor is yours. Welcome.
Thank you. Thank you, dear Mr. Chairman. I'm glad to see you all today in such interesting and unusual format. And I would like to tell you today about service-oriented Petri network model. It is quite popular in modern culture to take a big application and split it into little chunks called microservices. Each microservice can be responsible for a set of particular functions. It would have its role, and it can be implemented in any language you choose. This allows us to create flexible, yet quite massive and frequently updated large distributed applications that are currently working for us at Netflix, Uber, Google, Facebook, Amazon, etc. Every one of these giant corporations use as its main business a multiple services in a distributed application manner that run together, communicate with one another, and allow for quite efficient and seamless experience for the end user. End user doesn't see that there are tons of applications each time he makes a request. Yet, all of these services are made by people and tend to fail. And when we want to model this process, why interaction of service A that is written, for example, today is broken with a service that was written down, say, 5 years ago, it is quite hard. And if we look at, for example, formal modeling aspect of it all, if we take formal modeling languages such as TLA Plus and COQ, it takes quite astonishingly long time to describe any process in a fair detail. So like 10,000 lines of code to describe a simple core operations system functions. So there shall be some middle ground between directly testing how your application works in the distributed system on real clients, and 10,000 lines of code that you need to write to develop and describe a simple application such as main operation system functions. Now, if you look at the ways we can get to this middle ground, one of the most easy and probably familiar way for most users would be Petra networks. Yet they exist for more than 30 years, and still they are not widely spread or spread enough so that everyone would be using them to model their applications, because they are either strictly formalized and made so that it is complicated to model your system in Petronet formalism, or they are too simple for your needs and they won't cover them. So we wanted to develop some middle ground approach, some middle ground set of restrictions that would be based on service Petronets, and being simple, provide enough flexibility to describe your distributed application systems. So first of all, we developed modules that cover timing, that allow for setting timed goals and making a composite transition that would happen after a given set of time has explicitly passed, locking mechanisms that allow us to force system behavior that would stop and pause all other transitions before your complex transition has finished. And thus we get to more user-friendly and programmer-styled ways of how you describe your traditional operations, such as copy, move, etc. We brought functional transitions that allow us to describe operations such as combinations of such operations such as copy and move. We developed an interesting switch extension, and they are all based on service Petronet, so they are direct extensions to it and are fully described in service Petronet formalism. Yet they provide flexible extension-based mechanism that allows users to describe complicated functions in a repeatable manner, so they can really describe functions, they can be sure that these functions can be brought to new models, and they can be sure that if a function needs to take some amount of time in a given flexible models, it can take so. The other big problem that we've covered is integer operation by default in colored service, in colored stochastic Petronets and in simple stochastic Petronets models. They tend to use markers as a piece of data that can be only transported one by one. And we allowed for complex data types such as integers, where you can create a transition that requires all items of a certain place. And here place is shown like a circle in blue to be taken from, for example, N, and for example, from the circle K. So all the items that are in there, and via your transition to be summed or distributed to the place where you want to bring them. And with this, we come to more interesting data structures such as arrays and complex memory that can be easily implemented in our extensions formalism, and to modules that allow you to describe a set of public place transitions, public places, and hide your main logic inside the module, provide a timing set to it, and be sure that if you've developed a module and tested its characteristics, you can reuse that modules once more in different applications and thus gain portability and testability. With this, I thank you for your attention, and I'll be glad to answer your questions.
Thank you, Oleg. Are there any questions from the audience, please?
Yeah, thank you for your presentation. I'm not really familiar with Petri nets, so could you briefly explain what could be modeled with Petri nets, what could be measured, and so what kind of problem could be solved with Petri nets?
Thank you for your attention. The main problems that are capable of being solved via Petri nets, and our particular base in this case called stochastic Petri nets, are any Turing complete problems, because it is proven that stochastic Petri nets, which we are entirely based on, are Turing complete. So you can take any mathematical or development problem you have at your hand, describe it in a form of a module, so hide most of its logic inside say a box, provide a set of public places that are inputs for this module, and a set of public outputs that you know will be fired when the transition in great manner is executed. For example, when your service have finished its work, it can call a transition. Say, for example, here we have a juice and change transitions that can be called when all the apples are consumed and all the sugar is consumed, and we'll call this transition. And with this, you can generally implement any kind of particular service logic you want and keep it visually appealing, quite simple to understand for an external viewer. And the thing that was, in our opinion, quite harming stochastic Petri nets, you can bring integer-based and complex type-based arithmetics and operations into Petri nets. So I encourage you to look into our paper and see the way that we expand stochastic Petri net mechanisms that are Turing complete and thus can model any problem with some extensions that we try to make to simplify the life of Petri net end user, so that you can take any distributed process you have and bring it on to Petri nets. Thank you.
Yeah, thank you.
I have a small question, Oleg. So how close is this to real practical application? So if you tried to compare it with some actual existing cases that work and to see how your model is close to them.
So there are quite a short amount of practical Petri net implementations that are in use today. Main ones are called colored Petri nets, and they are generally focused on taking this approach of taking places, putting data sets into them, and operating in terms of one mark, like you see in here, that is representing only one item of any particular time, traveling through the network at a particular moment in time. So you take one by one marks and you migrate them throughout your network. While we are focusing on integers and allow you to create more complex types. For example, you can create a set of fixed amount of integers to create an array. You can take a set of fixed amount of arrays to create your particular data type, and you can, in our formalism, operate entirely on top of these types. So the same thing you generally see in traditional programming languages. You don't operate on particular marks, but you operate on type instances, and this is the main difference between our implementation and our development and what you can see currently in production in terms of Petri nets.
Thank you. So I propose to move on, and if we have more questions, then we can discuss in the end of the session. And the next presentation is done by the group of authors, Professor Bogdanov, Degtyaryov, Sheguleva, Khvatov, and myself. And I will be doing this presentation. So my name is Vladimir Korkhov. And let me share my screen. Can you see this?
Yes.
So this talk is about data virtualization, and in particular big data virtualization. And the motivation of this work is based on that the last years showed a breakthrough in data generation and data consumption, especially in this big data part where a lot of data is produced, a lot of users are there to consume that. A lot of storage exists of different configurations and of different capabilities, and the problem is to map users with the data. And one of the natural ways to solve this type of problems would be introduce the virtualization layer. So the layer that would abstract the actual users of the data from the particular sources, particular types of the data, and would help to simplify the usage and would help to simplify the access to the data. So our approach is to see from the top, to see from the users, and try to understand what the requirements of their applications, and with the virtualization layer, try to provide all those capabilities that are required. So in our research, we developed the concept of personal virtual supercomputer that is based on virtualizing computing, networking, storages. And here in this work, we try to introduce also the data virtualization, and we use one of the existing virtualization network, DGT networks, that we try to combine with our virtual supercomputer solution. So briefly about the data virtualization and its evolution. So traditionally, there are 3 generations, starting from the corporate storage or enterprise data warehouses that were focusing on collecting and structuring useful data that then was processed with the so-called data marts or special data views that were configured by the clients, by the data users themselves. Then the classical big data is based on data lakes that are collections of various data, and normally it's monolithic systems. And finally, the virtualized big data is based on so-called data marketplaces that work with the distributed and heterogeneous data sources that are collected in the logical data stores that are then represented in the views convenient for the end users. So we come the road from the focus on the storage layer to the focus on the consumption layer. And the responsibility goes from the data consumer, in the case of corporate storages, to the data producer. So he needs to sell his data in a way that is convenient for the users. So in this approach, there are benefits and issues. So there are a lot of benefits, so why we should look into it. So first of all, users get the data in a convenient form, and they can also get the latest data provided by the different producers. He doesn't see the actual source of the data, but he gets what he needs, as in all the virtualization cases happen with computing, with networking, here with the data. But there are several issues. So the data quality, the user should be able to check the quality and be sure that the data is good. And we will talk about this tomorrow in the blockchain workshop, or the talk will be presented about actual data quality, how we can do it and how we can use ledgers for that. Problems of confidentiality, how we can control the access in such virtualized infrastructure, and monetization. So how the producers of the data are paid to support and maintain their data sources. There are several principles. Many of them are partitioning, isolation, and encapsulation of the data, which brings significant changes in the approach to the data. And it introduces the specific capabilities that should enable this data as a service approach, which brings the need of the data API, the need of special data catalogs, special queries and optimization of the data access mechanisms, and the security, of course. All this data lifecycle in the virtualized world can be split to 3 generic layers, from the storage and consolidation to analysis and processing and to data representations. So on the lowest level, you can see this famous 3 letters CAP, consistency, availability, and partition tolerance. So this is the question how the data storages are organized. And there is a famous Brewer's theorem that is used to describe the storage, but it can also be applied to the data actually. So when we talk about the data in virtualized world, we can transfer these characteristics to the data itself. And Professor Dektarov already slightly introduced this concept in his talk earlier today about the virtual testbed. So we can see the data in these different types that provide either consistency or availability or different combinations of these qualities. So there are several classes, and we will not go into detail now to describe all of them. But depending on what the user wants and what the data are, they can have one or another capabilities, and they can have tools that are suited best for handling these types of data. The next layer, the second layer, was about the data processing, and there are now 2 major architectures that are used to process data, and especially it refers to the streaming data. So Lambda and Kappa architectures, while Lambda is more heavy and has more components, and it's suited for processing both streaming and batch data. Kappa architecture is more lightweight, mostly working with streaming data, but it also has capabilities to process batch data with specific configurations. So they do not really compete, but they can be used together for different cases. For example, for historical data analysis, Lambda suits better, or for fast processing, Kappa would be better. Finally, the highest level is basically the new paradigm of looking at data is a distributed data network, where we move away from the monolithic central storages and we come to the combined distributed heterogeneous storages that are distributed across different domains, and every domain presents its own data that is then handled by the virtualization layer. And to create this virtualization layer, there are a number of requirements for formal virtual data model. So we should take care especially about the APIs. So the APIs, how to access data, should be carefully worked out. The abstract representation of data, which is suitable for virtualization, also should be provided. Confidentiality and also this combination of different architectures, Lambda and Kappa, should be taken into account. And the central part of this virtualization layer is data marketplace, and that's the place that connects data producers and data consumers, or data sellers and data buyers in this logic. So that's the place where the applications, the end consumers can shop for data, so they can select particularly what they need exactly in that format that they need. And the virtualization layer is taking care about filtering, pre-processing, and providing exactly the same type, the same data that the user wants. And there are already a number of these marketplaces. One of them is GDT Network that we work together with, and we try to incorporate it in our solution of virtual supercomputer. And the virtual supercomputer is generally a concept of creating application-centric environments with configurable networks, computing characteristics, memory, and now we also try to introduce the data part in it. There already existing applications, marketplaces, except the DGT. There's also an IOTA Foundation that provides such a marketplace, and with Internet of Things devices sharing and selling their data that can be then acquired by the marketplace by different consumers. So finally, the conclusions are that the data virtualization is a next step of looking at the data. So it's not only a modern approach, but a new way of seeing the data. And the main goal of it is to simplify access and to use data as a service. This approach has a number of characteristics, and our practical work is to try to use this thing in our major development virtual personal supercomputer. Thank you for your attention, and I would be happy to answer your questions.
Vladimir, Vladimir, can I ask you about the process of consolidation? Because a classical approach is that consolidation is a part of more general integration process. Consolidation assumes that you use full ETL process, extraction of the data, transformation of it, and loading. So you mean really consolidation or the more general thing, integration of data?
So it's not only consolidation and integration, but it's a new representation of the data, basically. So you get the different sources, and they can be different formats. And you have to agree on the API, how this data is provided. And then the consumer might want to get a bit something else. So not all the data that you get, but particular views, particular filtering. And that's what this virtualization layer provides. So I would say it includes all these parts. So it's in the middle layer that we have this 3-layer structure. Yeah, so this data analysis and processing is basically this part that would take the integration questions, consolidation questions, and the virtualization would represent it for the users in the way convenient to them.
I think more general.
More general, yeah, more general, yeah. So it's more like a concept also.
Thank you.
And I also have a little question, if you please. Could you please describe what is big data virtualization in simple terms, in like 1 or 2 sentences, just to explain it a little bit better?
In simple terms, it's a way to simplify access to data, and well, by collecting the distributed sources together, but not with consolidation like in a data lake with centralized storage of this data, but a way to provide single way to access distributed data in a way that consumers want to work with it. The easiest way to work with it.
Thank you.
If there are no more questions, I would propose to move on. And the next talk is by Elena Stankova, Irina Tokareva, and Natalia Dyachenko on the effectiveness of using various machine learning methods for forecasting dangerous convective phenomena. I think Irina Tokareva will be the presenter.
Yes, hello, can you hear me?
Yes, welcome.
Okay. And here's my presentation, can you see?
Yes.
Okay, great. Good afternoon to everyone. I would like to present the talk on the effectiveness of using various machine learning methods for forecasting dangerous convective phenomena. Modern numerical models are widely used for dangerous convective phenomena forecasting. Nowadays, this task is very relevant because of the destruction that they produce. In this work, we combined numerical simulation and machine learning methods to identify the dependence of phenomena occurrence on different dynamic, microphysical, and electrical parameters of convective clouds. This kind of identification is very important for forecasting, for example, thunderstorms with the help of models that do not have the block that describes electrical processes. Modeling of a convective cloud has been conducted by the use of time-dependent 1.5 dimensional model with a detailed description of microphysical processes. The picture here shows the program that performs the calculation of cloud evolution. On the left, you can see various cloud parameters that can be the cloud model is calculating. In the center, you can see the cloud development field, and on the right, there is an aerological diagram. Red line here represents the dew point temperature, and black one shows air temperature. Input data was collected with the help of integrated information system. The numerical model of convective cloud simulates the whole cycle of natural cloud evolution consisting of 3 stages: the stage of development, mature stage, and dissipation stage. The output results are produced for every time step and every space step. So the problem is what time and height should we choose? So we will use cloud parameters as the object features. We considered 3 different approaches for different machine learning methods. The first approach, in the first approach, we fix cloud parameters with on the time moment that corresponds to the mature stage of cloud evolution, and on the height where maximum ratio of water droplets is observed. Feature selection here has been provided by using recursive feature elimination algorithm with automatic tuning of the number of features selected with cross-validation. In the second approach, we considered 5 cases with the different values of time and height. So later we can see how these parameters affect the results. For time values, we chose time moment that correspond to different stages of cloud evolution, and for height values, we chose the height with the maximum ratio of water droplets and the heights 300 meters higher and lower. For each case, individual sets of features were selected using the L1 regularization method. In the third approach, we again used the time moment of maximum cloud evolution and the height that corresponds to the maximum ratio of water droplets. The most significant features here has been selected using the recursive feature elimination algorithm with random forest algorithm as an estimator. The first approach of data formation and preprocessing was used for support vector machine, logistic regression, and rich regression. They show the accuracies of 97.7, 98.6, and 98.1% correspondingly. The second approach is used for the same methods as the first, and it allows to investigate the influence of cloud evolution stage upon the choice of cloud parameters. Here we can see 2 tables that represent the results for different cases. From the results, we can see that logistic regression showed the worst results, and the best ones were achieved with the use of support vector machine in case 2. The choice of the time moment of cloud evolution does not influence much upon the forecast accuracy of 3 methods. So we basically can choose any time moment of cloud evolution to use cloud parameters as object features. Although the influence of the height is more noticeable, the best results has been achieved in oh, I think I messed up presentation a bit. Okay, so the second table here should be case 1, case 2, and case 3. I'm sorry. So the best results has been achieved by using support vector machine is in case 2, which corresponds to the height that is 300 meters lower than the height of the maximum mixing ratio of cloud droplets. Third approach of data formation and preprocessing was used for neural networks. First, we used a multi-layer perceptron because it is classical structure used in classification problems. The network that gave the best accuracy is shown on the picture, and the accuracy is 89.1%. Perhaps such low accuracy was due to the use of a small data set. So we applied one of the methods that help to solve the problem of small data sets. It consists in the use of perceptron complexes. We considered 2 types of the perceptron complexes. The first one is shown here, and its accuracy is 90%. And the second one is shown here, and its accuracy is 91.6%. In this work, we continued to examine the effectiveness of using various machine learning methods for forecasting dangerous convective phenomena. This table shows the results obtained both in this and previous works. We considered in total 5 different machine learning methods, and the table contains the best accuracy that was achieved by a method, regardless of the data formation and preprocessing algorithms. As you can see from this table, the best results were achieved with the use of boosted k-nearest neighbor algorithm, and the worst one were achieved with neural networks. But all the obtained values of forecast accuracy should be treated as preliminary results, since feature selection methods and approaches of data formation are different for all the cases, and the data sets used are relatively small. So in future, the research should be focused on obtaining the sufficient number of data sets for forecasting. Thank you for your attention.
Thank you, Irina. Are there any questions to Irina, please?
Yeah, I have a little question. Could you please explain in simple terms what difference is between, say, 2% forecasting error and 3% forecasting error in your table in the last slide? So what practical difference is such small for the end user?
Okay. If I understand the question correctly, I can say that here we have a very small data set. So I think the 1% difference is 1% difference means that one more case was predicted correctly. Is this what you mean? I don't know. Maybe I.
Yeah, thank you.
Okay.
It's more clear now. Mhm.
Okay.
I have a very small question about the neural networks. So did you have any special approach to select the architecture that was more like a wild guess?
Yes, I had, since again the data set was small, I considered different architectures with 1 and 2 layers in this, in the case of multi-layer perceptron, and different number of neurons in each layer. And I just ran the process for each one of them and saw which one gives the highest results.
Okay, so the poor result is probably by this small learning data set.
Maybe, and also maybe because of not enough preprocessing, I guess.
Okay, thank you, Irina. We have to move on. We are a bit behind the schedule now. So the next talk is by Oleg Yakushkin again. It's a group of authors: Yegor Budlov, Oleg Yakushkin, Ekaterina and Olga Smirnova, or Rockman. So welcome, Oleg. Welcome again. Yes, it's good.
Yes, hello everyone. Hello everyone one more time. And today I'm presenting a work that is closely related to the one presented today before about how virtual supercomputers can help our development and research. And we developed a system that allows archaeologists to take their nice and interesting archaeological sites, the research they already have, for example, blueprints and depictions of archaeological artifacts and archaeological sites, and to bring these nice and complicated structures to life. As you may know, today there are a set of problems with archaeological realistic visualizations, and they are mainly related to the problem of low amount of real life models, low amount of real life textures, and our work tries to solve this. First of all, in any real archaeological work, there will be reports, and those reports will contain such data as outlines of each and every stone that was found on a given site. Furthermore, generally, archaeological reports are expanded by photographs and depictions of the real site. So we looked at a simple problem of how you can take an image and an outline and create firstly a three-dimensional model of an outline that was developed by us in previous papers, a texture from a single photograph, and to combine this information into a single model that would have color, texture, depth, and have interesting and complicated map. So we've developed a way to take a photograph and bring it into a set of textures in our previous works, and now in this work we combine them together, so we have a three-dimensional stone or three-dimensional artifact, and we combine it with a texture model that we gain from a single picture. First of all, we've largely compressed the original given image texture. Then we've looked upon a model, and when we've got our colorless model, we've looked at where we can create seaming and do UV unwrapping in a manner that would be respectful to the end user, so that, for example, a designer or a painter could then work on top of this model. So the chunks in this UV layout should be as big as possible while maintaining model information such as, for example, where the edges are and what large pieces of the model we are looking at for any model that we've automatically generated. So the texture and the model needs to be aligned, and for this we've created different instruments and materials. For example, here you can see that in typical model renderings there can appear seams, and we developed a subsystem that allows us to mask those seams so that the seams won't be actually visible for the end user. And you can see it, for example, in these two depictions of blue and reddish materials. And here you can see them in motion if we, for example, would try to rotate one or another. And this is how it looks in rendering software. So we have two approaches to how the end user can interact with our system. First of all is as a Blender extension. User adds our script system to the Blender software and then just uses it as a typical add-on. Probably this user has lots of added extensions before. And the second approach is to use it as a standalone Docker container. So a user can just provide us with a photograph and a three-dimensional model, and we can automatically generate from this data a texture, apply it to model, run UV unwrapping, run texture smoothing and seam stitching, and provide user with an end model that can be editable or integratable into a three-dimensional gaming engine or any other modeling software. So here are some timings of our system that you can see. It can run on Windows, it can run in Linux and Docker, and it can run on rather large models, creating nice materialized textures for them from just a laser scan or, for example, a three-dimensional photograph. The other interesting thing that this system that we developed brings is ability to make seamless cuts, so that, for example, your model would be looking destructible and the texture that is applied to it would stay seamless. So we firstly cut model in half, apply our texture, stitch it together, and we can depict it in full state and it in broken state. So you can access our software via this link. It is all open source and publicly available. And with this, I thank you for your attention, and I would be glad to answer to your questions.
Thank you, Oleg. So please, questions to Oleg. I have a small question. So this 3D model, do you generate it yourself or you get it from the end user?
We work on both ways. So you can, for example, take your own any three-dimensional model you have. You can have some special artifact that you scanned using laser scanner, or you can have a statue that you already have in some three-dimensional assets dataset, and you can just take any material you want, one photo of this material, and we can take this photo, this three-dimensional model without a texture or any material, and apply your material that we've extracted from your photo to this artifact or sculpture or three-dimensional scan. And the second thing we do is we allow you to take your typical archaeological report that would contain outlines, take any two outlines you have and generate from them a three-dimensional textureless model, which you can then texture and materialize using any material you want. So both approaches are supported. having a model and not having a model, but just having a archaeological report is okay with us.
Thank you. Do we have more questions to Oleg? If not, then thank you for your talk. And we have a small break, like 10 minutes, till the next session. And the next session will be chaired by Natalia, I think. So thank you and see you in some 10 minutes.
Thank you. Thank you, Vladimir.
Thank you.
Thank you. So before we start, I'll test. Can everyone hear me?
Yes, yes.
Okay, that's great. So I think we will start now, and we will continue our workshop with the next speaker, Alexey Beloshapka, with his talk about KLT beam detection and post-estimation in an industrial environment. He's a postgraduate student of St. Petersburg State University and also a junior researcher in the Robert Bosch GmbH. So please, Alexey, start.
Yeah, thank you, Natalia, for the introduction. I will try to share, a bit complicated. Screen, right? Okay, so yeah, thank you for coming here. I will present you some research on KLT beam detection and pose estimation in an industrial environment, which I carry on at Robert Bosch department in Russia. So the main object of our investigation is these KLT beams, which you see on the slide. These plastic transport boxes, which are used heavily in production plants and sometimes at warehouses. The main goal is to develop a software which allows a robotics system to search for these plastic KLT beams in 3D space and grasp them with some robotic gripper. These KLT beams are typically located at the shelves. Also, they can be located at conveyor belts, at the floor, or even at another robot, the AGV robot, which usually is used to carry these boxes around at the factories. Well, we detect this. We studied the detection of these KLT beams in many scenarios, but the most important ones is when the camera is aligned with the KLT beams, so that they appear from either from the side or from the top. So only one side of the KLT beam is visible. This is a very typical case at the production. And also, this assumption allows us to use the pose estimation algorithm, which I will describe later. The overall pipeline, software pipeline, which we developed to handle this task is as follows. We use a color depth Intel RealSense camera to capture both color image and also a depth image, which roughly captures the shape of the area which is captured. After that, a masker CNN neural network is used to search for a beam image on the color image. This network generates a proposal region for each KLT bin. So if there are many KLT bins on the image, then it produces many proposals. Then for each such proposal, we crop the corresponding region from the depth image and form a point cloud out of it. And then we estimate the 5 degrees of freedom pose by just applying the plane fitting algorithm. Basically, we use the open source implementation for that also. On this slide, you can see the, well, really rough pipeline of the Maskersian network, which is quite state-of-the-art in the object detection instance segmentation by now. And also on the slide, you can see the images that we used to train this network. So we captured a lot of PLT bins from different views, even from the views where it is not like aligned, when 2 sides of the KLT bins are visible, or even 3 sides. Some of them with the cover, other ones without the cover. And yeah, performed the classical image augmentation technique, so that to enlarge the dataset variety. And also we used a less common technique to augment the image is that we replaced the background image of the color image, because usually we capture KLT bins in not that much scenes, and the background is, well, it appears more or less the same all the time. So we wanted to avoid that, and that's why we replaced the background for each color image. No, well, as well as for the depth image. And to estimate the pose of the KLT bin, we used a simple algorithm, plane fitting algorithm, which just takes the part of the point cloud and fits their plane, so that we know the center, the KLT bin center from the color image, and also we estimated the distance to it from the fitted plane, as well as we know the tilt angles of the plane. But we cannot estimate the KLT bin Z rotation, the rotation around the image axis, unfortunately. And this is for future investigation, I think. Yeah, but at the moment, usually we assume that the camera is aligned with the KLT bins it observes. And that's why, well, we can bear with that and use only 5 degrees of freedom pose, or convert it to 6 degrees of freedom by applying this assumption. And the methods that we use to evaluate the accuracy of plane fitting is that we put a large checkerboard on the background. Well, we put the KLT bin on the large checkerboard, and then we are able to track the camera position with this checkerboard with a high accuracy. Because the KLT bin occupies some part of this checkerboard, we use arc markers at the white cells of the checkerboard, so that we can, well, label each corner of the checkerboard with its ground truth 3D coordinates without any ambiguity. If we were not putting these markers to the checkerboard, then sometimes we may assign wrong 3D labels to each checkerboard corner, and then have troubles with integrity of the measurements. So we yeah, put this Charco board, put the KLT bin on top of it, and then captured a lot of images of this setup. We estimated the camera position at each time with the checkerboard pattern, and also we measured the KLT beam relative position with our algorithm. This made us possible to express the coordinates of the KLT beam in the global frame, which is connected to the checkerboard pattern, and then evaluate some statistical, evaluate the accuracy statistically. So basically, we evaluate precision. On these two tables, you can see the numerical evaluation of both steps, the masker CNN detection and the KLT beam pose estimation with plate fitting. As you can see on table 1, yeah, we considered 3 different cases: the vertical view, as I discussed, the horizontal view, which looks at the KLT beam from a side, and the general view when well, we observe at least 2 sides of the KLT beam. So this is the case when the camera is not aligned with the KLT beam. And we evaluated the true positive rate, detection rate, false negative rate, and false positive rate. You can see that the detection rate is usually very good, except for the horizontal view, when a lot of KLT beams got not detected by the masker CNN network. We think that this is due to that the KLT beam appearance is yeah, it's really hard to capture. It has no texture and little shape information. They are usually just rectangular. And so we observed that if the KLT beam was not in the training data set, usually it doesn't get detected by the masker CNN. So the masker CNN network does not well generalize over the KLT beam types, but it generalize well on the spatial poses. So if you change the view on the KLT beam, if it was already trained before, then it will be detected without problems. So you can see the true positive rate is quite high all the time, and we almost never label the just environment as a KLT beam. So we distinguish well between the environment and the KLT beam. And the segmentation accuracy, the segmentation masks that are produced by masker CNN and used then to crop the point cloud are usually also of very good quality. And the plane fitting algorithm, which is applied further to the cropped point cloud, we evaluated it with the charcoal board tracking, as I discussed, and we measure the we estimate the sensor of the KLT beam and collect the statistics about its estimation in the 3D global frame. So the average deviation of the KLT beam sensor from its global average is around 3 centimeters all the time. This is that are not very good values, I would say. So the accuracy is not sub-centimeter. Well, there could be 2 possible reasons for that. First of all, the masker CNN network, of course, it produces not the perfect masks, so that could bring some additional error, additional drift of the position. But also the method that I used, the Jericho tracking, was developed by myself and probably it has some issues. So I would suggest you to treat these values as the well, the upper boundary estimate. The maximum deviation from of the center from the global average was about 10 or 15 centimeters, which is quite large. This is like the well, how it's called. Well, this is the outlier estimate. We could also further treat this, deal with this outlier estimates by applying some filtering, like introducing Kalman filter around along several views of on the QLT bin, so that we address the issue with that we have some outlier, because Kalman filter are able to detect outliers if they do not fall well into the statistics. Yeah, and the variation of camera movement was, the average movement was around 20 centimeters. So yeah, that's briefly all about this investigation. Further, I guess it would be good to introduce this Kalman filtering, which we didn't introduce yet, to address, first of all, address the outlier detection, and also improve the precision of the system. So that's it. If you have some questions, I would like to answer.
Thank you, Alexei. Some questions? Any questions?
Yes, please. Alexei, would you comment about the figures represented in the table 1 and 2? You have, I think, 4 figures after the comma. So do you estimate somehow the error of these figures, the error of the results? Because it seems too exact, 2 figures after comma.
You mean that I use, for each numeric value, I use 4 digits to express the accuracy, right?
So you know all measurements in physics have error. You are not able to measure something without inputting error in your result. So if the length of something is 1 meter, it's not exact from physical point, from the point of view of physics, because you have 1 meter plus minus, I think, 0.5 centimeters or millimeters. Maybe some estimations about error of these results.
Okay, so yeah, first of all, table 2, it represents the estimation of the error of the plane fitting method. So yeah, this pipeline of Masker-Snell followed by plane fitting. Of course, it has some pose estimation error, and I wanted to estimate this accuracy with the checkerboard tracking. And you can see the values on the table too. What's about the method that I used to evaluate the accuracy? Usually it is treated as state-of-the-art and doesn't get errors larger than 1 centimeter. So usually it is sub-millimeter, I would say, if you get good enough camera. But as I did the implementation by myself, I would say that, yeah, it's kind of hard to tell which accuracy the tracking method has. So yeah, I don't have these values at the moment.
Thank you. I take it into attention.
Yeah, thanks. Thank you for your suggestion.
And other questions? I have a small one. Am I right that the problem is with if there is the problem is with the environment behind the QLT bin that is on the picture. It depends on what is behind the box.
Well, let me scroll to some images. Well, I don't have typical images here because they are kind of secret. Well, yes, the accuracy of the at least Masker-CNN segmentation really depends on the background. Well, what's in the background of the QLT bins. So for simple views, like on the left picture, when you have just floor with some texture, usually you get really good results without problems. But if the environment, as it happens, also contains straight lines, and as KLT beans also doesn't have enough texture as KLT beans, then yeah, probably this really affects the accuracy of masker CNN, well, the detection rate, and well, etc. But that's why we learn on the KLT beans. If the masker CNN method is has learned a KLT bean, already observed it once in the training set, then most probably it will safely out-segment it from the background without ambiguity. Well, up to some certain cases where it usually fails. For example, if some straight lines goes really near to the boundary of the KLT bean and is aligned, then sometimes we get drift of the sheet mask. But this happens not that often. Most of the time, if we train the KLT bean, then it doesn't matter what background do you have, and it works well. If you didn't train the KLT bean, then yeah, as you can see from the values of table 1, it's even a problem to detect the KLT bean, and yeah, especially if background contains something which is similar to KLT bean, then sometimes you also get problems.
Okay, thank you. And I think we need to move on to our next speaker, who presents the work detection and localization of embedded subtitles in a video stream, and this work will be presented by Sanjan Valery. He's a postgraduate student of St. Petersburg State University. I guess.
Sanjan, where are you? He was here.
Yes, I knew.
Just want to. I will call him.
Yes, please. While we're waiting for Sanjan, I will give an announcement about our next speaker, Alexandra Tikhomirova. She's unfortunately absent, and we were planning to start the pre-recording presentation of her work, but there are some technical problems, and there is no voice on the record, so her presentation is in red, and everyone who wants to see can connect and have some questions, can connect to Alexandra by email and ask her questions about her presentation. And I think now we can return to Sanjan Valery and his presentation.
Sanjan. Oh, okay.
Okay, we can hear you.
Okay, do you see me?
Yes.
Yes.
Okay, I am doing my presentation.
Share it, please.
Yeah, I share it.
Oh,
yes,
yes.
We see.
Oh, we see.
Are you seeing? No?
Yes, we can see her. the screen, but not the presentation.
We see the nested screen.
Do you see the screen?
The screen, yes.
And the
Yes.
presentation? The
Now, yes.
presentation?
Okay, okay now.
Now it's okay.
Okay. Yeah, I'm Saint Jean Valery, and will talk about the detection and localization of embedded subtitles in a video stream. I did the work with my supervisor, Valery Grishkin. And now nowadays we saw the video with external subtitles constitute a part of modern video. Then here we see that some video image with a subtitle. We have two kinds of subtitle. We have external subtitle where we use software and hardware added by a video player. The characteristic of this kind of external video subtitle is that the subtitle can be easily replaced. But for our work today, we will be focused about the embedded subtitle, where the texts are overlaid on a video frames. Okay, where the video is divided on two types. The text located on the syntax, or if the text is embedded outside the source. We see here the feature of embedded subtitle. The embedded subtitle on almost all frames of the video is presented in one language. Normally is the same size, front and orientation image. I'm sorry, they are doing something of my wasn't for the. Do you hear me very well? Hello, hello.
Yes, we can hear you and see the presentation. Everything is okay.
Okay. In addition of the embedded subtitle has temporal homogeneity. The frequency of the text change does not exceed a certain value, and for a certain period, the text itself does not change, nor does its position or orientation. This feature makes it possible to distinguish subtitle from a complex background, including the syntax and localize the position of subtitle. The simple method for the one used to detect the recognized text in the trend. Here we say, like I talked, we have two types of subtitle. Some are embedded subtitle, those are the syntax, it's where it's on the text. The syntax too have some feature because the same text come with variety and variable different frame of video and can be written in several language. Quality of switch in the image cannot be guaranteed due of the shooting condition. That's the feature of the syntax. In this slide, we have, when we did the work, we did it for our method and our program which we built via OpenCV. That the method which we did for the localization of subtitle in video stream. The way we did is, we take the essence of the method of the search for the static region, because we take every image and we take a static region. In the frame of the image, we do an analysis and connect area with this region in order to determine whether the region belong to subtitle area. It's mean we take the image and we make a processing image for every body of the text, and by this way we can check if we have subtitle or if we don't have subtitle. For that, we do the background model, which built of several frames to the video. Based on this model, a binary background image mask is generated. An analysis of connected component reveals that static region in this mask, some of which may include subtitles. Then, using heuristic rules and analysis of the mean of the relationship parameter of static region, which reveals the of 1000 relation of this region group to subtitle. Yeah, after taking the method of the detection, we use the pre-processing method. It will be the next slide. In this slide, we say different steps of pre-processing. The input is the video stream, and to work with, we have to change the parameter of the video at first. The first way, what we do, we change the frame of the size. We resize the video. Forget after that, after resizing that, we convert it to grayscale. Why we convert it to grayscale? We convert the grayscale to the image to help a network to work much quickly, because we have a lot of parameters. Because if we had RGB like red and many color, the computer will have many parameters to work. Then here at grayscale, we did it. It will be quickly 4 or 5 times, 4 or 5 times faster. After that we do the background and the foreground object, where we propose a method of Gaussian mixture model. Since the text and subtitle does not change for several frameworks, the subtitles belong to the background. Applying this method yields binary frame image mask, foreground and background, which constitute the result of processing. The background mask is binarized in using the adaptive threshold before further processing to the resulting mask, and subject of the morphological imaging opening operation to all the eliminate posing in high frequency noise. There, here we use we use the adaptive binarization here. For that, remove some noise, and what we want to change the image and black or white, because it's giving two, like for example, it's giving two sides of one, perhaps for example 125 or 2055. If the frame is under 125, it will be text 0. It will be the image will be black, and up to 125, it will giving the 2055. It will be white. It's the image thresholding, and after the future we will see we will have black or white imaging. That we see on the next slide. After pre-processing, we see what the first image is there, and what we do is, after converting the grayscale, removing all the noise, and now we have this new property of this image. That means it will be ready for the to work into the software. Then we have a subtitle detection. For static region, which we take on for any part of the image, we take a pixel reference, like in the static area segmentation. After the segmentation, is connected to component search method is applied to binary background mask. The result is grayscale image in which the brightness of each pixel corresponds to the number of the static region to which this pixel refer. In addition, segmentation process create a list of this region. It's for after the processing, the software makes some filter sorting for the area by the vertical coordinate, and we will have some coordination and a coordination vertical. And we will do filtering for the area in the list because we won't take, the software will not take all the area. And he will sorting by the horizontal coordinate at the center of its quantity area and make the clustering. And we get the result. We get the result of the binary background which we take with the mask. What we see on the static region of segmentation, where after segmentation of the static region, we see this pixel refer and addition segmentation for each inter-region described by a parameter. This set, we see the coordinate and size bounding here for the rectangle of used for subtitle. Now we can see that the subtitle is around this border because it's in this border because we have the bound who is statical here. And we go to the subtitle detection. We see, like we did before, the list of region is filtered by occupied area. Since the region with subtitle symbol have a relatively small area, only region having an area that live in certain range, included the filtered list. Any text character has a form factor which is defined as a height to weight ratio of that character. For that character of the most common font, this ratio lies in a certain limited frame. That we have the after having some rectangle bounds, we see the static region here that we can see that after the pre-processing, after the binary thresholding, we know that the detection and the detection of the location of the subtitle can be in this area. We can see it on the next slide that here normally text line of subtitle are oriented, you see usually they are oriented horizontally. In other words, the text line of the subtitle is displayed as a set that the distribution of the, we take some horizontal, some coordinate x and y descent should be demonstrated on certain periodicity. Here we see the periodicity of the bounds here, and that they are usually horizontal. That's what we can find. Think the subtitle is in this area. Okay, and we listed of the region is sorted by the vertical coordinate here, and between adjacent vertical coordinates are calculated here. We calculated here the resulting of this 1000 areas divided, and this line we have the periodicity in horizontal distance between the center of the region. Okay, we go to the subtitle localization. Here we see at the localization of the position of each line of subtitle here. After the list of the area being part of the subtitle line are identity, and the search of the parameter of bounding rectangle is performed both of each distinct text line and for the entire subtext area. This search utilizes information about localization and size of local area bounding rectangle. We can create here to a distance between the center of the region. In the horizontal directional clustering procedure is also applies here. If the range of the distance in the 1000 class is not too big, we can contain some succinct text string here and list of the bounding box of the subtitle line and subtitle bounding box. Yeah, it's that bounding rectangle which with for the subtitle for above the localization lines and the entire subtitle array in the binary max in the video frame melee. The subtitle array detected by the method are slightly smaller than the real array. That's what we see here. And the proposed expand to the calculated bounding rectangle by 5%. This allows you to more accurately localize the area of the subtitle. And after that, after the detection, after the localization, we can go to the experimental result. In the experimental result, we see that some of them we see we can localize the subtitle like here and here, and some of them we can see if they have subtitle or if don't have subtitle, and we can see if they have false subtitle. For this work, the proposed method which we detect and localize in this for that subtitle is implemented in C++ and using to the MGU OpenCV computer vision library. Are supported for the GPU platform, computing and experimental verification to the method. The subtitle is that video were in different part of the frame, came on the different size and color. However, can enough contrast the result of the localization subset shown here. What we can see here, the resulting process speed even without using GPU always to process the video stream and extract this embedded subtitle. Okay, thank you for your attention. If you have some question.
Thank you. We have, I think, time for one small question.
Sorry?
I think we have time for one small question.
Yeah.
If there are no questions, I have this small one. Maybe I'm not clear. What methods are used to detect the subtitles?
Yeah, we use the method OSER. It's very usually, but we perform the method OSER. We perform it. We take what was it better, but we put him strongly and quickly. Then we write our own code with OpenCV.
Okay, thank you. Let's thank the speaker again, and I will repeat my announcement about the next speaker, Alexandra Smirova. She's a doctor, and she's working while serving people, and so we can't start her pre-recorded presentation by some technical problems. So her presentation is in Riot, and you can look at it there. And another announcement by Rafael is in our Jitsi chat about the opening ceremony and the keynote speaker of today. Please read it, and for that, I think we stop this part of our workshop, and the next one will be soon after the official opening ceremony and keynote speakers. So thank you, and look for future events.
Thank you, Natasha.
Yeah, thank you.
Thank you.
Thank you.
Thank you to all the speakers.
Thank you.
See you later today.